Imagine that every star isn't just a light, but a story that began long before we were here. Today you'll learn the most amazing facts about space, about time that you can actually see, places where light disappears, and scales that are impossible to comprehend. If you enjoy these peaceful journeys through the universe and want to support the channel, subscribe and give it a like. It helps create new stories that are a pleasure to revisit before bed. And now, let's take a closer look at the sky. For most of human history, the night sky was a fixed thing. That was simply how it felt, how it looked, how it behaved, how every civilization on Earth experienced it across thousands of years of careful watching. You went outside after dark, and there they were, the stars, exactly where they had always been, tracing the same slow arc from east to west as the hours passed, returning night after night in their familiar patterns. The ancient Egyptians used them to align their pyramids. The Phoenicians used them to navigate the open sea. The Greeks named them, connected them with lines of imagination into heroes and animals and gods, and told stories about them that their children's children's children would still be telling 2000 years later. The sky was eternal. The sky was unchanging. The sky, it turned out, was doing something that no one had imagined possible. The first hint came not from looking at the sky directly, but from doing something far more painstaking, measuring it. In the early 20th century, an American astronomer named Henrietta Swan Leavitt was working at the Harvard College Observatory, working, technically, as a human computer, one of a group of women hired to measure and classify photographic plates of stars, a job considered too tedious and detailed for the man who ran the institution. The pay was low, the credit was slow in coming, but the work was real, and Leavitt was exceptional at it. She discovered something in a particular class of stars, stars that pulse, brightening and dimming with a steady, reliable rhythm, that turned out to be one of the most valuable tools in the history of astronomy. The longer a star's pulse, the more intrinsically luminous it was. Always, without exception. This meant that if you measured how long a star took to pulse, you could calculate its true brightness. And by comparing the true brightness to how bright it appeared in the sky, you could calculate exactly how far away it was. Leavitt had given astronomers a ruler long enough to measure the universe. When her ruler was applied to the faint, blurry patches of light that astronomers called nebulae, cloud-like smears scattered across the sky that no one had quite been able to explain, the results were staggering. Another American astronomer, Edwin Hubble, used Leavitt's method in the 1920s to measure the distance to one of these patches, a smear of light in the constellation Andromeda. The answer came back so large that it took time to believe it. The Andromeda Nebula was not a cloud of gas inside our own stellar neighborhood. It was an entire separate galaxy, a collection of hundreds of billions of stars, sitting roughly 2.5 million light years away. Our own galaxy, the Milky Way, was not the whole universe. It was one island in an ocean of islands, each island itself containing more stars than there are grains of sand on all the beaches of the earth. That discovery alone would have been enough for several lifetimes. But Hubble was not finished. He kept measuring, and as he measured more galaxies and more distances, he noticed something that made no sense at first. Something so counterintuitive that it took the scientific community years to fully absorb. The galaxies were moving away from us. Not just one or two, not in some particular direction. All of them, in every direction, on every side, the galaxies were receding. And here was the truly strange part. The further away a galaxy was, the faster it was moving. There was a precise mathematical relationship between distance and speed. Double the distance, and the recession speed doubled too. Triple the distance, triple the speed. This pattern, now called Hubble's law, though the Belgian astronomer Georges Lemaitre had derived it mathematically 2 years before Hubble's observational confirmation, a priority dispute that took the scientific community nearly a century to fully acknowledge, had only one logical explanation. The universe was expanding, not the galaxies moving through space, like birds flying outward from a tree. Space itself was growing, stretching, the way dots drawn on a balloon spread apart when you blow air into it. The galaxies were not going anywhere. The space between them was increasing, carrying the galaxies along like raisins in a rising loaf of bread. The implications of this took time to work through, but they were not difficult to follow once you started. If the universe was expanding now, if everything was growing further apart with every passing second, then running the process backwards in time meant that everything was once closer together, much closer. The further back you went, the smaller and denser and hotter the universe became. Run the film back far enough, and all the matter and energy in the observable universe, every star, every planet, every atom in every molecule of every living thing, was compressed into a space unimaginably small, at a temperature unimaginably high. And then something happened. The moment of the universe's beginning is called the Big Bang, though the name is misleading in almost every way. It was not an explosion in the ordinary sense. There was no surrounding empty space for something to explode into, because space itself was part of what began. It was not a bang, because there was no medium for sound to travel through, and no one to hear it. It was, as far as current physics can determine, the beginning of time itself, the moment before which the question what happened before may not have a meaningful answer, because before requires time, and time did not yet exist. This happened approximately 13.8 billion years ago. To put that number in some kind of perspective, if the entire history of the universe were compressed into a single calendar year, with the Big Bang at midnight on the 1st of January, then our solar system wouldn't form until early September. Complex life would not appear on Earth until mid-December. All of recorded human history, every empire, every invention, every war, every song ever written, would occupy the final 14 seconds of the 31st of December. The expansion has not slowed down since. If anything, it has accelerated. In 1998, two independent teams of astronomers studying a particular kind of stellar explosion called a Type 1a supernova, which burns with such a consistent brightness that it can serve as a measuring beacon across billions of light years, made a discovery that overturned what everyone had assumed about the universe's future. The expansion of the universe was not gradually decelerating under the pull of gravity, as most physicists had expected. It was speeding up. Something was pushing the universe apart, counteracting gravity on the largest scales, driving the galaxies away from each other faster and faster with every passing epoch. This something has been given the name dark energy, a label that is more placeholder than explanation, an honest admission that we have observed an effect whose cause we do not understand. Dark energy appears to make up roughly 68% of everything in the universe. We do not know what it is. There is also dark matter, a different mystery, something that exerts gravitational pull and holds galaxies together from the inside, but which emits no light of any kind and has never been directly detected. It makes up roughly 27% of the universe, which means that all the ordinary matter we can see, measure, touch, and name, all the stars and planets and gas clouds and galaxies, all the hydrogen and helium and carbon and iron, everything that has ever been observed through every telescope ever built, accounts for approximately 5% of what actually exists. The universe is 95% mystery, and yet that 5% is enough to be astonishing. There are more stars in the observable universe than there are grains of sand on every beach and desert on the surface of the earth. The observable universe, the portion we can see, limited by how far light has had time to travel since the Big Bang, is about 93 billion light years across. Beyond its edge, the universe almost certainly continues, in directions and dimensions we cannot observe, perhaps forever. The Milky Way alone, our own galaxy, contains somewhere between 100 and 400 billion stars. It takes light traveling at 300,000 kilometers per second, roughly 100,000 years to cross it from one side to the other. Our sun sits about 26,000 light years from the center, in a quiet, ordinary spiral arm, an unremarkable star among hundreds of billions. None of this was known 100 years ago. Leavitt had not yet found her pulsing stars. Hubble had not yet pointed his telescope at Andromeda. The universe, for all its billions of years of silent expansion, had been keeping its scale a secret. It gave that secret up slowly, reluctantly, only to those patient and precise enough to measure it. And what they found, when they finally looked carefully enough, was that the sky, that ancient, familiar, supposedly fixed and eternal sky, had been moving all along, quietly, constantly, in every direction at once. It is still moving now, as you read this. The galaxies are still drawing apart, the space between them still stretching, the universe still becoming, moment by moment, slightly larger than it was before. It has never stopped, not for a single second, in 13.8 billion years. And it will not stop tonight. On a clear night, far from the glow of any city, lie down on your back and look up. What you are doing in that moment is not quite what it feels like. It feels like looking out, like pressing your face to a window and seeing the universe spread beyond it. But that is only half the truth. The other half is stranger and more beautiful and takes a moment to settle properly into the mind. You are also looking back. Every point of light reaching your eyes has been traveling to find you. Some of it left its source a handful of years ago. Some of it has been crossing the void for centuries. some of the faintest smudges are visible on the darkest nights, barely there, at the very edge of what the human eye can detect, are light that began its journey before the earth existed, before our sun had ignited, before the solar system had condensed out of its spinning cloud of gas and dust. That light was already old when the first oceans formed on this planet. It has been traveling ever since, through the absolute cold and silence of intergalactic space, and it ends its journey in your eye on an ordinary evening, unremarked. The night sky is not a view, it is an archive. This is a consequence of a fact so fundamental that it is easy to forget how strange it truly is. Light travels fast, but it does not travel instantly. In the vacuum of space, light moves at approximately 299,792 kilometers per second, a speed so high that it circles the Earth more than 7 times in a single second, a speed that makes almost every other velocity in ordinary human experience seem like standing still. And yet, against the distances of the universe, even this extraordinary speed is humblingly slow. Light from the sun takes about 8 minutes to reach the Earth. This means that when you glance at the sun, briefly, carefully, you are not seeing it as it is. You are seeing it as it was 8 minutes ago. If the sun were somehow to vanish at this moment, we would not know for 8 minutes. We would continue to feel its warmth and see its light for 8 more minutes, living in a reality that had already ceased to exist. The moon is closer. Light from its surface reaches us in about 1.3 seconds. But the nearest star beyond our sun, a dim red dwarf called Proxima Centauri, sits 4.24 light years away. The light you see when you look at it left its source roughly 4 years ago. You are seeing Proxima Centauri as it was in the recent past, not dramatically different, perhaps, but genuinely the past nonetheless. Now extend that principle outward, and the sky begins to change. Sirius, the brightest star in the night sky, blazes from a distance of 8.6 light years. The light it sends you tonight is light from 8.6 years ago. Betelgeuse, the reddish star at the shoulder of the constellation Orion, is somewhere between 500 and 700 light years away. Astronomers have found it difficult to pin down precisely, because measuring stellar distances at that range involves layers of calculation and assumption. The light from Betelgeuse, reaching your eyes tonight, left that star during the Middle Ages, before the printing press existed, before Columbus crossed the Atlantic, when the Black Death was still a living memory in the villages of Europe. Betelgeuse is also, by astronomical reckoning, near the end of its life. It is a red supergiant, an enormous, bloated, unstable star that has burned through most of its fuel and is approaching the moment when it will collapse inward and then explode in a supernova, an event so energetic that it will briefly outshine the entire galaxy, visible from Earth even in daylight. Astronomers believe this will happen within the next 100,000 years, soon by cosmic standards, though not quite soon by human ones. It may have already happened. The explosion may have occurred centuries ago, and the light from it, that vast pulse of brightness, may already be traveling toward us, unaware that we are waiting, due to arrive some night when someone looks up and sees, in the familiar shoulder of Orion, something that was not there before. The star cluster called the Pleiades, the Seven Sisters, visible to the naked eye as a tight knot of blue-white stars in the constellation Taurus sits about 440 light-years away. The light left them around the time Galileo was building his first telescope, just beginning to turn it skyward and see what no human eye had seen before. There is something quietly pleasing in this. Galileo looking up with his new instrument, and the light that would confirm his findings, in some sense, already on its way. The Andromeda Galaxy, that smear of ancient light visible on dark nights in the northern hemisphere, is 2.537 million light-years distant. The light arriving from it now left its source before the genus Homo existed, before our ancestors had begun the long, slow process of becoming human. Australopithecus was walking the savannas of Africa when that light began its journey. The ice ages had not yet begun. The light has crossed more than 2.5 million light-years of expanding space, has passed through the gravitational fields of countless objects, has never once slowed or paused or faltered, and arrives tonight, quietly, as a faint smudge near the constellation Perseus. Beyond Andromeda, the distances become difficult to hold in the mind. The Hubble Space Telescope, launched in 1990 and still operational in its successor instruments, has imaged galaxies so distant that their light has been traveling for over 13 billion years. In 1995, astronomers pointed the telescope at a tiny, seemingly empty patch of sky near the Big Dipper, a region about 1/30th the apparent diameter of the full moon, and held it there for 10 consecutive days, collecting every photon that arrived. The resulting image, called the Hubble Deep Field, revealed approximately 3,000 galaxies in that single tiny patch of apparently empty sky, each one a collection of hundreds of billions of stars, each one seen as it was billions of years ago. In 2022, the James Webb Space Telescope extended this reach further still, capturing images of galaxies that formed within the first few 100 million years after the Big Bang, the earliest structures in the observable universe, seen as they were when the cosmos was less than 5% of its current age. The light in those images is the oldest light ever directly observed by human instruments. It has been traveling for over 13 billion years. It predates the Earth by nearly 9 billion years. There's a boundary to how far back we can see, and it is a genuine boundary, not a limitation of our instruments, but a physical wall built into the nature of light and time. For the first 380,000 years after the Big Bang, the universe was so hot and dense that it was opaque. Light couldn't travel freely through it. Photons were constantly scattered by the plasma of charged particles that filled all of space. The universe was a blinding fog, impenetrable to light. Then, as the universe expanded and cooled, something changed. The plasma settled into neutral atoms, and the fog lifted. Light was free to travel for the first time. The photons that had been trapped in that fog streamed outward in every direction, and they have been traveling ever since. We can detect them today as a faint glow of microwave radiation arriving equally from all directions. The cosmic microwave background, the oldest light in the universe, the afterglow of the moment the cosmos first became transparent. It is the furthest back we can ever see. Before it is silence, not because nothing existed, but because nothing that existed then could send us light. There is something worth sitting with in all of this. Every photon that reaches your eye has survived a journey of almost incomprehensible length. It has crossed distances that make the whole of human histories look like a single footstep. It has passed through the deaths of stars and the births of galaxies, through clouds of gas and dust, to the slow curve of space-time bent by gravity. And it has arrived, intact, carrying information about a source that may no longer exist, in a universe that has changed enormously since the journey began. When astronomers talk about looking at distant objects, they talk about looking at them as they were, not as they are. There is no as they are, not at these distances. There is only as they were, the past arriving continuously in the present, the sky a layered record of time, stretching back almost to the beginning. The stars you see tonight are messages. Most of them were sent before any human being existed to receive them. They found you anyway. There are places in the universe where the rules stop working. Not in the way that rules sometimes bend under pressure or stretch at the edges or apply differently in unusual circumstances. The ordinary flexibility that science is comfortable with and has learned to account for. These are places where the fundamental laws that govern everything we have ever observed, everything we have ever measured, everything we have ever built a theory around, reach their limits and go quiet. Where our best mathematics produces answers that are not very large or very small, but genuinely meaningless, infinities that signal not a discovery, but an admission. We do not know what happens here. These places exist. They are real. They have been observed, measured, and studied with increasing precision for over a century, and they are among the most extreme environments the universe has produced. They are called black holes. The idea arrived before the evidence did, as ideas in physics often do. In 1783, a British clergyman and amateur scientist named John Michell sat down and worked through a thought experiment using Newton's theory of gravity, which had been the reigning framework for understanding motion and force for over a century. Michel asked a simple question. If gravity can slow down a projectile fired upward from the Earth's surface, and if you make a star massive enough and dense enough, could gravity become strong enough to slow down light itself? Could a star exist from which light could not escape? He called them dark stars. He published his idea in a letter to the Royal Society. The letter was read, noted, and largely forgotten for nearly 200 years. Then, in 1915, Albert Einstein published his general theory of relativity, a complete reimagining of gravity, not as a force acting between objects across empty space, but as a curvature of spacetime itself. Massive objects do not pull on each other across a void. They bend the fabric of space and time around them, and other objects follow the curves. The Earth orbits the Sun not because the Sun is pulling it, but because the Sun's mass creates a curve in space-time that the Earth follows, the way a marble rolls around the inside of a bowl. Within months of Einstein publishing his theory, a German physicist named Karl Schwarzschild, working at the Russian front during the First World War, writing his calculations while artillery fired in the distance, found an exact solution to Einstein's equations that describe the space-time geometry around a perfectly spherical mass. The solution worked beautifully for ordinary objects like stars and planets, but it contained something disturbing at its center, a point at which the equations broke down completely, producing values that made no physical sense. Schwarzschild died of illness at the front before he could investigate further, but his equations survived, and over the following decades, physicists slowly and reluctantly accepted what they implied. A black hole forms when a sufficient amount of mass is compressed into a sufficiently small space. The most common pathway is the death of a very massive star. Stars are at their core a balance of forces, the inward crush of gravity, which wants to collapse the star, and the outward pressure of nuclear fusion, which resists it. For millions or billions of years, these forces hold each other in equilibrium, and the star burns steadily. But fusion requires fuel, and fuel runs out. When the core of a sufficiently massive star exhausts its nuclear fuel, the outward pressure stops. Gravity wins, instantly and catastrophically. The core collapses inward in a fraction of a second, an event of almost unimaginable violence, and the outer layers of the star are blasted outward in a supernova explosion, bright enough to briefly outshine an entire galaxy. What remains at the center, if the original star was massive enough, is something from which there is no return. The defining feature of a black hole is its event horizon, a boundary in space, not a physical surface, not a wall or a membrane you could touch, but a point of no return. Cross it, and the physics of the situation becomes absolute. No object, no signal, no information of any kind can escape back across the horizon. Not because the gravity is pulling with irresistible force, though it is, but because inside the event horizon, the geometry of space-time itself is distorted so severely that all possible paths through space and time lead inward. There is no direction that points out. Every direction points towards the center. This is the detail that makes black holes genuinely different from merely very strong gravity. It is not that escape would require moving faster than light. It is that space and time inside the horizon are arranged so that inward is the only direction that exists. The boundary of the event horizon is determined by mass. For a black hole with the mass of the Sun, which our Sun will never become, being far too small, the event horizon would be a sphere about 3 kilometers across. Compress the mass of the Earth into a black hole, and the horizon would be the size of a marble. The more massive the black hole, the larger the horizon, in direct proportion. At the center of the event horizon, the equations of general relativity predict something called a singularity, a point of zero volume and infinite density, where all the mass of the black hole is concentrated. The word infinite here is a signal that the theory has broken down. General relativity, which handles the very large with extraordinary precision, cannot be the complete story at scales this small. At those distances, quantum mechanics, the physics of the very small, must also apply. But our current theories of general relativity and quantum mechanics are mutually incompatible at these extremes. The singularity is where our ignorance lives. What actually happens at the center of a black hole is one of the deepest open questions in physics. The effects of a black hole on space-time extend beyond the event horizon. One of the predictions of general relativity, confirmed repeatedly by observation and experiment, is that gravity slows time. The stronger the gravitational field, the slower time passes relative to a distant observer. This effect, called gravitational time dilation, is not science fiction. It is real enough to affect the clocks on GPS satellites, which run in a weaker gravitational field than clocks on Earth's surface, and must be corrected to remain accurate. Near a black hole, this effect becomes dramatic. An observer falling toward a stellar mass black hole would experience time normally from their own perspective, but as seen from a safe distance, they would appear to slow down as they approached the event horizon, their movements becoming more and more sluggish, their signals becoming more and more redshifted and stretched until they appeared to freeze at the horizon itself, dimming gradually into invisibility. From the outside, they never quite cross. From their own experience, they cross almost immediately and find themselves somewhere from which no report can return. Black holes are not rare. At the center of almost every large galaxy in the observable universe, including our own Milky Way, sits a supermassive black hole, objects millions or billions of times more massive than the Sun, whose origins and growth history are still not fully understood. The black hole at the center of our galaxy, called Sagittarius A star, has a mass of about 4 million suns. It sits 26,000 light-years from Earth, behind dense clouds of gas and dust that block visible light entirely, detectable only through radio waves, infrared radiation, and X-rays. In 2019, the Event Horizon Telescope, a global network of radio observatories, coordinated to function as a single telescope the size of the Earth, produced the first direct image of a black hole shadow. The supermassive black hole at the center of the galaxy, Messier 87, 55 million light-years away. The image showed a bright ring of superheated gas surrounding a dark central region, the shadow cast by the event horizon, light bending around it rather than escaping. It was the first time human eyes had seen, however indirectly, the edge of a place from which nothing returns. In 2022, the same collaboration produced an image of Sagittarius as star itself, our own galaxy's central black hole, imaged for the first time. There are also stellar mass black holes scattered throughout the Milky Way, the remnants of massive stars that ended their lives in supernova explosions. Estimates suggest our galaxy contains somewhere between 10 million and 1 billion of them. Most are invisible, detectable only when they interact with a companion star, pulling material from it in a stream that heats to millions of degrees and glows in X-rays. One of the strangest recent discoveries is a class of black holes that appear to lie between stellar mass and supermassive, intermediate mass black holes ranging from hundreds to hundreds of thousands of solar masses. They are difficult to find and poorly understood, and their existence raises questions about how black holes form and grow that current models cannot fully answer. The universe, it turns out, is full of places where our understanding ends. Black holes are the most dramatic, the places where two of our greatest theories break down simultaneously, where time bends and space closes, where the familiar rules of cause and effect become geometrically impossible. But they are also, in a strange way, among the most productive mysteries in science, because every question they raise points towards a deeper theory that must exist beyond our current understanding. Something lies on the other side of what we know. We have not reached it yet, but the edge is visible, and that is closer than we have ever been before. Our instinct, when we think about other planets, is to imagine something like home, perhaps a little colder or a little warmer, perhaps with two moons instead of one, or a thicker atmosphere, or oceans of a slightly different color. Our imagination, even at its most ambitious, tends to stay anchored to the familiar, to what we know a planet can be, because we have lived our whole lives on one. We adjust the dials of our experience slightly left or slightly right, and we call the result an alien world. The universe has not been nearly so conservative. What exists out there, confirmed by observation, measured by instruments, documented in the scientific literature with the careful, restrained language of people who are nonetheless clearly astonished by what they are recording, is far stranger, far more worried, and in many cases far more hostile than anything our intuition would have suggested. The history of exoplanet astronomy, which is barely 30 years old as a serious scientific discipline, has been a continuous exercise in having expectations overturned. The first confirmed detection of planets orbiting another star came in 1992, and it arrived from an unexpected direction. Astronomers had been searching for planets around sun-like stars, reasoning that these were the most promising candidates for Earth-like worlds. What they found instead were planets around a pulsar, the rapidly rotating remnant of a dead star, a dense sphere of neutrons about 20 kilometers across, spinning hundreds of times per second and broadcasting regular pulses of radio waves with the precision of an atomic clock. Alexander Wolszczan and Dale Frail, analyzing timing data from the pulsars designated PSR 1257 plus 12, detected tiny irregularities in the pulsar's pulse rhythm that could only be explained by the gravitational tug of orbiting bodies. There were planets there, around a dead star, in an environment bathed in intense radiation, orbiting an object that had survived one of the most violent events in the universe. It was the last place anyone had thought to look, and it was where planets were first confirmed beyond our solar system. 3 years later, in 1995, the first planet around a sun-like star was confirmed. It was found orbiting 51 Pegasi, a star about 50 light-years away in the constellation Pegasus, and it was immediately, profoundly strange. The planet, designated 51 Pegasi b, has roughly half the mass of Jupiter, a gas giant. This alone was unremarkable, but its orbit was something else entirely. Jupiter, in our solar system, orbits the Sun at a distance of about 778 million kilometers, taking nearly 12 years to complete a single circuit. The planet around 51 Pegasi orbits its star at a distance of approximately 8 million kilometers, about 50 times closer than Mercury is to our Sun, and completes one full orbit in 4 days. It was so close to its star that its surface temperature was calculated to be around 1000 degrees Celsius. A gas giant, an object the size of Jupiter, sitting far closer to its star than Mercury sits to ours, completing a year every 4 Earth days. Nothing in our theories of planetary formation predicted this could exist. The current understanding was that gas giants could only form in the cold outer regions of a solar system, where ice and gas could condense. They should not be close to the stars. They could not have formed there. This particular class of object, a gas giant in an extremely close orbit, acquired a name, Hot Jupiter, and 51 Pegasi b, far from being an anomaly, turned out to be the first of hundreds. Our models of how planetary systems form had to be substantially rebuilt to account for planetary migration, the process by which giant planets can form in the cold outer regions and then drift inward over millions of years, ending up in orbits nobody expected. With better instruments and new techniques, the catalog of known exoplanets grew rapidly. The Kepler Space Telescope, launched by NASA in 2009, spent 9 years staring at a single patch of sky containing about 150,000 stars, watching for the tiny dimming that occurs when a planet passes in front of its star. Over its operational lifetime, it confirmed more than 2,600 planets, and the statistical analysis of its data suggested that virtually every star in the galaxy hosts at least one planet. The Milky Way, it became clear, contains hundreds of billions of planets, more planets than stars, when moons are accounted for. The range of what Kepler found defied easy summary. There are planets with densities lower than balsa wood, vast, bloated objects so inflated by the hate of their nearby stars that they are more foam than world. There are planets denser than iron, small enough to hold in both hands if you could somehow survive the approach. There are planets in binary star systems, orbiting two suns simultaneously, experiencing sunsets that no human imagination had quite managed to produce before the data confirmed they existed. There are planets orbiting three stars. The sky is crossed by a geometry of light and shadow that changes in patterns no simple calendar could track. Among the strangest confirmed worlds is one designated HD1 89733b. It is a hot Jupiter, deep blue in color, one of the few exoplanets whose actual color has been measured, determined by detecting starlight reflected from its atmosphere. From a distance, it would look almost like a larger, vivid version of Earth when seen from space. Up close, it is nothing like Earth at any level that matters. The temperature on its surface, or rather, in its atmosphere, since it has no solid surface, exceeds 1000 degrees Celsius. Its winds travel at roughly 8,700 kilometers per hour, more than 7 times the speed of sound. And what falls as rain in its atmosphere is not water, or methane, or anything else the solar system has accustomed us to expect. It rains glass. The silicate particles that condense in HD 189733b's upper atmosphere are swept horizontally by the winds at such speed that they do not fall so much as blast sideways across the planet in a continuous horizontal storm of superheated silica. It is not a place. It is a process, a continuous howling, lethal process, with no ground to land on and no shelter of any kind. At the other extreme of strangeness is a planet designated 55 Cancri E. It orbits its star so closely, completing a year in 18 hours, that its surface temperature is thought to reach approximately 2,400 degrees Celsius, well above the melting point of most rock-forming minerals. Early analyses of its composition and density led to the extraordinary suggestion that a significant portion of its interior might consist of carbon under conditions of extreme heat and pressure, conditions under which carbon forms its densest crystalline structure. The suggestion, reported carefully and with appropriate caveats in the scientific literature, was that parts of 55 Cancri E might be composed of diamond. a planet with a diamond interior, scorched to temperatures that melt most metals, orbiting its star 3 times faster than the Moon orbits the Earth. Later analyses have complicated this picture, as is normal in a young field working with incomplete data. The composition remains uncertain, but the basic facts, extreme proximity, extreme heat, exotic chemistry, are confirmed. Then there are the worlds on the other side of strangeness, the ones that are almost tantalizingly familiar. The TRAPPIST-1 system, announced in 2017, contains 7 Earth-sized rocky planets orbiting a small, cool red dwarf star about 40 light-years away. 3 of them sit within the habitable zone, the range of orbital distances where liquid water could potentially exist on a planetary surface. All 7 are close enough to their star that they are probably tidally locked, meaning one hemisphere always faces the star in permanent daylight, while the other faces the cold of space in permanent night. Whether any of them hosts liquid water or an atmosphere stable enough to support it remains unknown. The James Webb Space Telescope has begun examining the TRAPPIST-1 planets, and early results are cautious. One of the inner planets appears to have little or no substantial atmosphere, which is not encouraging, but the investigation is ongoing, and the other planets have not yet been examined with the same depth. There is a category of planet that does not exist in our solar system, but appears, based on Kepler data, to be among the most common type in the galaxy. These are called sub-Neptunes, or super-Earths, planets with radii between 1.5 and 3.5 times the radius of Earth, too large to be rocky worlds like ours, and too small to be gas giants like Neptune. They appear to come in 2 distinct populations, those with substantial gaseous envelopes, and those that have been stripped of their atmospheres by stellar radiation. The boundary between these 2 populations, a gap in the distribution of planetary sizes, known as the radius gap, was predicted theoretically before it was confirmed observationally, one of the cleaner predictive successes in the young field of exoplanet science. In 30 years, we have gone from knowing of 8 planets to knowing of more than 5,000 confirmed worlds, with thousands more candidates awaiting confirmation. The picture they collectively paint is not the ordered, comprehensible picture our solar system had suggested. It is wilder than that, more varied, more extreme, more indifferent to the assumptions we brought to it. Gas giants in 4-day orbits, glass rain at 7 times the speed of sound, diamond interiors, tidally locked oceans of permanent twilight, planets around dead stars, around double stars, around stars so small and dim that their habitable zones are closer than Mercury is to our Sun. Earth, seen against this backdrop, is not typical. There may be nothing typical in any meaningful sense. There's only the extraordinary variety of what gravity and chemistry and time can produce, given enough stars and enough opportunities. And there are, it seems, opportunities without number. The catalog is still growing. There is a number that is worth sitting with for a moment before we go any further. 1 followed by 24 zeros. That is the estimated number of stars in the observable universe. a figure derived not from counting it directly, which is impossible, but from measuring the light output of galaxies, estimating how many stars of various types would be needed to produce that light, and multiplying across the roughly 2 trillion galaxies that current observations suggest exist within the horizon of what we can see. Different methods produce slightly different numbers, but they converge on something in this vicinity. 10 to the power of 24, a septillion in the American counting system, a quadrillion in some European ones, a number so large that no unit of ordinary human experience gives it any purchase. For comparison, if you counted 1 star per second without stopping, it would take roughly 32 quadrillion years to finish. The current age of the universe is 13.8 billion years. You would need more than 2 million universe lifetimes just to count them. And that is only the observable universe, the sphere of space from which light has had time to reach us since the Big Bang. Beyond its edge, the universe almost certainly continues in all directions, perhaps without limit. Scale is the defining fact of the cosmos, and it is also the fact the human mind is least equipped to handle. We are built for the middle distances. Evolution shaped our intuitions to navigate a world of trees and rivers and the distance a person can walk in a day. We have a genuine, felt sense of the difference between a meter and a kilometer. We can imagine with some effort the distance across a continent. Beyond that, the numbers become intellectual rather than felt. We can say them, manipulate them mathematically, use them correctly in calculations, and yet not truly apprehend them in the way we apprehend the distance to the other side of a room. The history of astronomy is, in part, a history of human beings, discovering that the universe is larger than they thought, and then discovering that it is larger still, and then discovering that the revision was not nearly large enough. The ancient Greeks, who were careful and clever observers, debated the size of the earth and came remarkably close to the correct answer. But the stars, they assumed, were fixed to a rotating sphere not enormously far beyond the planets, perhaps a few thousand times the radius of the earth. The universe of Aristotle and Ptolemy was, by modern standards, a small, cozy, human-scaled place. The Copernican revolution of the 16th century expanded it considerably. If the Earth moved around the Sun, then the stars must be very far away indeed, far enough that the Earth's movement around the Sun produced no detectable shift in their apparent positions. The universe grew by orders of magnitude. Then Herschel in the 18th century mapped the Milky Way and found it to be a vast disk of stars, with our Sun somewhere inside it. The universe grew again. Then Hubble showed that the nebulae were galaxies, separate island universes, each containing hundreds of billions of stars, and the universe grew by factors so large that the earlier expansions looked like rounding errors. And then, in 1998, the discovery of accelerating expansion suggested that the universe will continue growing forever, its most distant regions eventually receding faster than light, disappearing beyond the horizon from which no signal would ever return. The observable universe is not just large, it is a shrinking fraction of the total, a bubble of knowability in something larger that we cannot, even in principle, ever fully observe. Against this backdrop, consider the distances within our own galaxy. The Milky Way is approximately 100,000 light years in diameter. Its central bulge, where stars are densest, is about 10,000 light-years thick. Our Sun sits roughly 26,000 light-years from the center, in a minor spiral arm called the Orion Arm. The nearest star to our Sun, Proxima Centauri, is 4.24 light-years away. If the Sun were reduced to the size of a grapefruit and placed in the center of a large city, Proxima Centauri on the same scale would be another grapefruit located roughly 2,400 kilometers away. The distance from one side of the Milky Way to the other, on this scale, would be larger than the actual diameter of the Earth. Between the grapefruits, nothing, or very nearly nothing. Interstellar space is not empty in the way a vacuum chamber is empty. There are gas atoms, dust particles, cosmic rays, magnetic fields. But by any standard a human being can relate to, it is as close to nothing as anything in nature gets. Space is mostly space, and it is silent. This is the other defining feature of the cosmos that is easy to state and difficult to truly absorb. Sound is a mechanical wave, a compression and rarefaction of a medium, moving through air or water or solid material by pushing molecules against each other in succession. In the vacuum of interstellar space, there's no medium for sound to travel through. The universe, for the vast majority of its volume, produces no sound. It cannot. The events that occur in it are frequently violent beyond anything the surface of the Earth experiences. Stars explode, galaxies collide, black holes merge in events that release more energy in a fraction of a second than our Sun will emit over its entire 10 billion year lifetime. These events send shock waves through surrounding gas, produce light across every wavelength of the electromagnetic spectrum, and, as was first detected in 2015, generate ripples in space-time itself, called gravitational waves, that travel at the speed of light and pass through everything in the universe, including the Earth and everyone on it, causing the fabric of space to stretch and compress by amounts smaller than a proton's diameter. All of this happens in silence. The shockwave of a supernova explosion, a sphere of expanding gas traveling at tens of thousands of kilometers per second, containing the energy output of billions of ordinary stars, moves through space without making a sound. The collision of two galaxy clusters, an event that will take hundreds of millions of years to complete and will fundamentally reshape billions of stars, happens in absolute quiet. We know about these events because they emit light, and light can travel through vacuum. Sound cannot. There is one genuine exception to this silence, and it comes from the beginning of everything. In the first 380,000 years after the Big Bang, the universe was filled with a hot, dense plasma, a medium through which pressure waves could travel. Variations in the density of the early universe created genuine sound waves, moving through the plasma of the infant cosmos. These waves left their imprint on the distribution of matter, an imprint that is still visible today in the slight clustering of galaxies at particular scales, in the pattern of temperature variations in the cosmic microwave background. Cosmologists have calculated the frequency of these primordial pressure waves, approximately 57 octaves below the lowest note a human ear can detect. The universe, in its infancy, was reverberating. It has been silent ever since the plasma cooled and the medium disappeared. Here then is where we arrive at the end of this chapter, end of this book. A universe 13.8 billion years old, 2 trillion galaxies wide, containing a septillion stars, expanding in silence in every direction at an accelerating rate, governed by laws we have spent centuries uncovering and still only partially understand, containing objects, black holes, neutron stars, magnetars, hot Jupiters, diamond planets that stretch the imagination past its comfortable limits, threaded through with light that has been traveling since before the Earth existed, carrying information about sources that may no longer be there. And on one small, rocky, unremarkable planet, orbiting one ordinary star, in one quiet spiral arm of one galaxy among 2 trillion, a species of large-brained primates has spent several thousand years looking up and asking questions. The questions keep getting better. The universe keeps getting larger. And somehow, improbably, the distance between what we know and what there is to know feels less like a cause for despair than for something else entirely. Something closer to the feeling you get when you open a very good book and realize, with a particular kind of pleasure, that you have barely reached the first chapter. Look up. The light is still arriving. Imagine a city that began with a campfire on a hill and grew to become the heart of the entire world. An empire where every road led to a single point, where the fates of millions intertwined like threads in a vast tapestry of time. Today you'll hear the story of ancient Rome, from the legend of the she-wolf to the quiet decline of the empire that changed the course of history. If you enjoy these journeys through the ages and want to support the channel's growth, subscribe and give it a like. It helps create new stories you can always revisit before bed. And now, open this page with me. Long, long ago, before the great cities rose and the roads stretched across the earth like threads of silver, there was a river. The Tiber moved slowly, the way rivers do when they carry secrets. Its banks were lined with reeds and willows, and in the evenings, when the light turned gold and the birds grew quiet, the water seemed almost to whisper. Of course, rivers cannot speak, but this one had much to remember. On the hills above the river, before anyone had thought to call them by name, the land was green and wild and full of possibility. Wolves moved through the long grass. Eagles turned lazy circles in the summer sky. And somewhere in the space between the forests and the open fields, a story was beginning. The kind of story that starts not with a plan, but with a miracle. The story went like this. There was once a princess, a gentlewoman of royal blood, who had been made a priestess against her will, kept from the world, kept from living any ordinary life. But fate, which cares very little for what people intend, brought her together with a god, Mars, the god of war himself, proud and blazing as a forge fire. And in the way of old stories, something extraordinary came of it. Twin boys. When they were born, her uncle, a hard man, the kind who feared what he could not control, ordered that the children be taken away and drowned in the river. He was the king, and he worried that 2 grandsons of royal blood might one day take his throne. So he gave the order, and his servants obeyed, as servants of cruel kings often do. But here is where the river kept its first secret. Instead of drowning the boys, the waters carried them gently to the shore. The basket that held them, some say it was a simple clay pot, others a wooden cradle, came to rest under a fig tree at the foot of the Palatine Hill. And there, as the sun warmed the mud and the world went about its business all around them, something impossible happened. A she-wolf came. She was large and silver-gray, with amber eyes and a low, careful step. She should have been frightening. She should have eaten them, but she did not. She lay down beside the twin boys, and she let them feed from her, as a mother would. She kept them warm through the cold nights. She guarded them until a shepherd, a kind man named Faustulus, found them at last and brought them home to his wife, and the two boys grew up in the hills, not knowing who they truly were. Their names were Romulus and Remus. You might wonder, did this really happen? Did a wolf truly nurse two babies on a muddy riverbank? Perhaps not. Stories, especially very old ones, tend to stretch and shimmer like heat rising from summer stone. What matters is not whether every detail is true, but what the story means. And this one means something important. It says that Rome was, from the very beginning, two things at once: wild and strong, dangerous and tender. It was raised on wolf's milk, which is to say it was shaped by fierceness, by survival, by the kind of toughness that cannot be taught, only lived. But it was also a place where the impossible could happen, where the river might carry you safely instead of swallowing you whole, where even a wolf might choose kindness. That is the soil Rome grew from. The twins grew into young men, fearless and capable, leaders even before they knew it. They gathered other young men around them, the bold ones, the restless ones, the ones who didn't quite fit anywhere else. They drove out the cruel uncle who had tried to have them killed. They found out who they truly were. And then, as happens when two powerful people share one dream, they disagreed. Where should the new city be built? Romulus wanted the Palatine Hill. Remus preferred the Aventine. They decided to let the gods choose, the way people did in those days, by watching the sky for omens, for the flight of birds, for signs. Remus saw 6 vultures circling above his hill. Then Romulus saw 12 above his. 12 was more than 6. Romulus declared himself the winner. Remus laughed at him, or mocked him, or leapt over the wall his brother had begun to build. The old stories aren't quite sure which. But something went wrong between them, in the hot, proud way that things go wrong between brothers, and Remus died. Whether by Romulus's own hand or someone else's, the earliest city was stained before it had even grown its first walls. This too matters, because Rome would always carry that shadow, the shadow of brothers in conflict, of greatness mixed with grief, of building something magnificent on ground that had already known pain. But life continued, as it must. Romulus built his city. He drew a line in the earth, a furrow they called it, made by a plow drawn by a white bull and a white cow. And that line was sacred. That line was Rome. It was small enough that you could walk around it in an afternoon. It had wooden gates and thatched rooftops, and fires at night that smelled of pine and animal fat. It was, by any reasonable measure, quite ordinary. And yet, Romulus knew that a city is nothing without people, so he made Rome into a place of welcome, or at least a place that asked few questions. He opened its gates to runaway slaves, to exiled men, to wanderers and debtors, and those who had nowhere else to go. They came from all across the hills and valleys. They came without much to offer except themselves. And that, it turned out, was exactly enough. Because Rome did not grow great by being pure or perfect or chosen. It grew great by being open, by pulling together people of every kind and making them, somehow, into something shared. The city was a mixing bowl, rough, noisy, argumentative, alive. There were early kings after Romulus, 7 of them, each one different. Some were wise, some were foolish. One was a great builder. Another, the last, was so proud and cruel that the people finally rose up and threw him out altogether. And when they had done that, they stood in the streets of their city and made a decision that would change the world. They would not have another king. Never again would one man hold all the power. Instead, they would share it, spread it out, argue over it, check and balance it, the way you might share a loaf of bread so that no single person gets too much. They called what they made a res publica, the public thing, the thing that belongs to everyone. We call it the Republic. But that is a story for the next chapter. For now, the city sleeps on its hills above the slow, secret river. The wolves have gone back into the forest. The fig tree still stands, or at least the memory of it does. And in the small, smoky houses on the Palatine, ordinary people, people who had run away from trouble and arrived somewhere new, are closing their eyes, listening to the Tiber moving in the dark. They do not yet know what Rome will become, but something is beginning, something that will, in time, fill the whole world. The word republic is old enough to have almost worn smooth, like a coin passed through too many hands. But once it was new and sharp, and it meant something that had never quite been tried before. It meant this: no single person should hold all the power. It sounds simple. It is not simple at all, because power, like water, always finds its way somewhere, and keeping it spread evenly, keeping it from pooling in one place, from flooding, from drowning everything around it, that takes constant, careful work. It takes laws and argument and people willing to push back even when pushing back is dangerous. The Romans, to their credit, understood this, and so they built something remarkable. At the top of it all sat the Senate, a gathering of Rome's most important men, gray-haired and serious, draped in white togas with a stripe of deep purple at the hem. They met in a building near the heart of the city, and they argued endlessly about taxes and roads and wars and treaties, about who should lead and who should follow, about the price of grain and the position of the stars, and 100 other things besides. Above the senators, and yet still bound by them, were 2 men called consuls. They were the highest officials in the Republic, and they ruled together, which is to say, each one could stop the other from doing anything too rash. They served for exactly 1 year, not a day more. Then they stepped down, and 2 new consuls took their place. This was deliberate. This was the point. If you can only hold power for a year, you cannot build an empire for yourself. You cannot stack enough stone to make yourself a king. The Romans had seen what kings did, and they had decided firmly that they would not have that again. Below the consuls were other officials, men with titles that sound musical even now: praetors and quaestors, censors and tribunes. Each one had a different job. Each one had limits on what he could do. The whole machine was designed to slow itself down, to make sure that no single voice drowned out all the others. It was imperfect, of course. The wealthy had more say than the poor. The old families had more say than the new ones. But the idea, the beautiful, difficult, stubborn idea at the center of it, was real. And it was new. And it mattered. Rome grew. First slowly, the way a fire catches, just an ember, then a small flame, then something larger. The city spread beyond its original hills. Nearby towns were absorbed, sometimes by war, sometimes by agreement, sometimes by the quiet gravity of a place that was simply too useful to resist. The Romans were not always gentle neighbors, but they were often surprisingly fair ones. When they conquered a people, they frequently let the people keep their customs, their gods, the local ways of doing things. They asked for soldiers and taxes in return. In exchange, they offered roads, laws, protection. It was a trade, unequal, yes, but not without something on both sides. This was how Rome learned to grow without breaking. Not by erasing what it found, but by adding to it, by making more room. By the middle years of the Republic, Rome controlled most of the long boot of Italy. And standing at the southern edge of that boot, looking out across the blue, salt-smelling water of the Mediterranean, Rome began to see something further away. On the other side of the sea, on the northern coast of Africa, there was a city. Its name was Carthage. Carthage was magnificent, rich and clever and ancient, a great maritime power with ships that moved across the Mediterranean like pieces on a game board. Its merchants traded in silver and silk and purple dye. Its generals were brilliant. Its navy was the finest in the known world. And it was growing in the same direction as Rome. What followed were 3 long, brutal, exhausting conflicts that the Romans called the Punic Wars. They burned across decades and across oceans, and they changed both cities forever, though only one of them survived. The first war was mostly fought at sea, and Rome, a city that had barely built a proper navy before, had to learn the art of sailing almost from scratch. They did. They lost ships by the hundreds in storms and in battle. They built more. They lost those too. They built more again. Eventually, grinding and costly as it was, Rome won. But the second war was the one that nearly ended everything. Carthage sent a general, a man of extraordinary skill and cold, precise intelligence, marching overland from Spain, across the great snow-capped spine of the Alps, down into the heart of Italy itself. His name was Hannibal, and his army included elephants, enormous and grey, thundering through mountain passes that no army was supposed to cross. For 15 years, Hannibal moved through Italy like a storm. He crushed Roman armies in battle after battle. At a place called Cannae, in a single afternoon, he destroyed the largest force Rome had ever assembled. tens of thousands of soldiers killed before the sun had moved far across the sky. It was one of the worst military defeats in the ancient world. And still, Rome did not surrender. That is perhaps the most important thing to understand about the Republic in its middle years. Not that it always won, but that it refused, with an almost frightening determination, to admit that it had lost. When Hannibal's messengers arrived carrying bags of gold rings taken from the fingers of dead Roman knights, expecting Rome to beg for peace, the Senate voted instead to keep fighting. They sent another army south, and another, and another. Hannibal could win battles. He could not win Rome's will. Eventually, the Romans took the war back across the sea to Africa itself, and Carthage was forced to recall Hannibal to defend his homeland. He was beaten at last on African soil at a battle called Zama. The war was over. Rome had survived. But survival changes people. The legions came home from those long wars harder than when they had left. The generals who had led them came home with something else too. Not just glory, but a taste for it. A hunger for the kind of respect that does not come from debating in the Senate or waiting your year as consul. The kind of respect that comes from 50,000 soldiers who will follow you anywhere. Meanwhile, the wars had shifted the land beneath Rome's feet in ways that were slow but deep, like roots splitting stone. Small farmers, while their sons were away fighting, had lost their fields to wealthy landowners who bought them up cheaply. The cities swelled with the poor and the landless, people who had nothing to sell but their labor, and increasingly, not even that, because wealthy Romans were buying slaves by the thousands, brought back from conquered territories to work the great estates. The Republic, that careful machine of checks and limits, had been built for a city of farmers and traders, all roughly equal, all with something to lose. It was not built for this, for an empire stretching across 2 seas, for generals with private armies, for hundreds of thousands of people with nothing and nowhere, and no stake in the way things were. Reformers tried to change things. Some of them were killed for it. The arguments grew louder, then angrier. The streets of Rome, which had once been the place where citizens went to vote and debate and be part of the great public thing, became places where fists flew, and sometimes blades. The Republic had not yet fallen, but it had begun, very quietly, to shake. On the Tiber, the river still moved in the same slow way it always had, carrying leaves and light and the reflections of torches burning on the banks. If you had stood there on a still night in those years, you might have heard the city humming with all its arguments and ambitions, all its fears and its future. Something was shifting, something vast and unstoppable, the way a tide turns. So gradually you cannot point to the moment, but real all the same. The next chapter would bring the storm. There is a river in northern Italy, smaller than the Tiber, quieter, easy to miss if you weren't looking for it, called the Rubicon. In the time of the late Republic, this river was not famous for its beauty, or its fish, or the towns that sat along its banks. It was famous for one thing only. It was a line, a boundary drawn not in stone or wood, but in law. On one side of the Rubicon lay the Roman provinces of the north, where a general might command his army and do as he pleased. On the other side lay Italy itself, and Rome, where no general was permitted to bring his soldiers. Not ever, not for any reason. The law was old and serious and very clear. To cross the Rubicon with an army was to declare war on Rome itself. It was an act that couldn't be undone, any more than a word spoken in anger can be pulled back out of the air. In the winter of 49 BC, a man stood on the northern bank of that small, cold river with his army behind him, and he thought about what he was about to do. His name was Gaius Julius Caesar. Caesar was not a simple man, and it would be a mistake to pretend he was. He was brilliant, dazzlingly, almost unnervingly so. He was a general who could read a battlefield the way a musician reads a page of notes, instantly, completely, seeing things others missed. He was a writer whose words were so clear and sharp they are still read today, 2000 years later, in schools across the world. He was charming in the way that certain people are charming, effortlessly, dangerously, in a way that made you feel, when he looked at you, that you were the most important person he had ever met. He was also ruthless and ambitious and convinced, perhaps correctly, perhaps not, that Rome needed him more than it needed its old rules. He had spent nearly a decade in the far north and west, in the wild provinces the Romans called Gaul, the lands that would one day become France and Belgium and parts of Germany. He had fought war after war there, against tribes of fierce and complicated people who resisted Roman expansion with everything they had. He had won, at enormous cost in lives on both sides. He had written it all down in clean, careful Latin, sending dispatches back to Rome so that everyone would know exactly what he had done. And what he had done had made him, to many Romans, something close to a hero. But back in Rome, powerful men were afraid of him. They saw what he was becoming, or what he already was, and they moved to strip him of his command, to bring him home as a private citizen, vulnerable to the enemies he had made along the way. They thought that without his army, he would be manageable, ordinary, stoppable. Caesar understood what they were doing, and on that cold bank, with the Rubicon moving dark and quiet before him and his soldiers waiting in silence behind him, he made his decision. He crossed. What followed was a civil war, Rome against itself, which is perhaps the cruelest kind of war there is, because everyone fighting knows the faces on the other side. Caesar moved south with astonishing speed, and city after city opened its gates rather than resist him. His great rival, a general named Pompey, fled across the sea to Greece with much of the Senate in tow, hoping to regroup, hoping the distance would give him time. It did not give him enough. Caesar followed, fought, and won. Pompey was killed in Egypt, betrayed by people he had trusted, and Caesar stood alone at the top of the Roman world. He was not cruel in victory, by the standards of the age. He pardoned many of his enemies. He made plans, serious, thoughtful plans, for reforming the calendar, rebuilding the city, restructuring the way the provinces were governed. He moved with the energy of a man who believes he can fix everything if only he is given the time. But time was exactly what his enemies were determined to deny him. In Rome, a group of senators, men who called themselves liberators, Men who genuinely believed they were saving the Republic made a plan of their own. They were led by two men of contrasting character: Cassius, who was sharp and practical and had personal reasons for his hatred of Caesar, and Brutus, who was something more complicated, a man of deep principle, a man Caesar had trusted and even loved, a man who convinced himself that what he was about to do was not murder, but medicine, that Rome was sick, and this was the cure. On the Ides of March, the 15th day of that month, in 44 BC, Caesar came to a meeting of the Senate. He had been warned. He had been told by friends and by a soothsayer who stepped out of the crowd to speak to him directly that this day held danger. He came anyway. Perhaps he did not believe it. Perhaps he was simply too proud to show fear. Perhaps at some level he could not have named, he was simply tired. The senators gathered around him as if with a question, and then the blades came out. 23 wounds, the accounts say. Caesar fell at the foot of a statue of his old rival Pompey, and the marble floor of the Senate ran red, and the men who had done it stood holding their daggers and looking at each other in the ringing silence that follows an irreversible act. They had meant to save the Republic. What they had actually done was something quite different. The death of Caesar did not restore the old order. It shattered what remained of it. Rome fell into chaos, a lurching, violent, miserable chaos that lasted for another 13 years, grinding through betrayals and alliances and battles and assassinations until the world was exhausted and desperate for someone, anyone, to make it stop. 3 men formed an alliance to avenge Caesar and carve up the Roman world between them: Mark Antony, who was Caesar's most loyal general; Lepidus, a capable man who would eventually be shouldered aside; and a young man, just 19 years old when Caesar died, who had been named in Caesar's will as his adopted son and heir. His name was Octavian. He did not look like a conqueror. He was slight and often unwell, thus prone to illness in a way that made people underestimate him. He had no great military genius. He relied on a brilliant general named Agrippa to win his battles for him, which is itself a kind of genius. What he had instead was patience and cunning and an almost preternatural ability to understand what people wanted and to give them just enough of it. He and Mark Antony, who had fallen deeply in love with the Egyptian Queen Cleopatra and made his home in her golden court on the Nile, eventually they turned against each other, as men who share power always seem to do, eventually. The confrontation came at sea, off the coast of Greece, at a place called Actium, in 31 BC. Antony and Cleopatra's fleet was broken and scattered. They fled back to Egypt, and when they understood that there was no escape and no future, they each chose to die rather than be paraded through Rome in chains. Octavian was left standing alone. He was very careful about what he did next. He did not call himself king. He had watched what happened to men who reached too openly for that word. He called himself instead the Princeps, the first citizen, and he spoke often and warmly about restoring the Republic, about returning power to the Senate, about being merely a servant of the Roman people. The Senate, exhausted and grateful-less and not entirely foolish, played along. They gave him a new name, a title, really, more than a name, that carried a sense of the sacred, of something set apart and luminous. They called him Augustus, and Rome, which had been a republic for nearly 5 centuries, became something new without quite admitting to itself that the change had happened. The Senate still met, the consuls were still elected, the old words were all still said in their old places. But when Augustus spoke, the world listened. And when he decided, that was what was done. The Republic was over. The Empire had begun. Augustus lived a long time, long enough to see the thing he had built settle into its own shape, the way fresh mortar slowly hardens into stone. He ruled for over 40 years, and when he died, an old man in a small town in southern Italy, the empire did not collapse, or fracture, or dissolve into the chaos it had so recently escaped. It simply continued. That perhaps more than any battle, or any building, or any law, was his greatest achievement. He had made something that could outlast him. He had given Rome not just an emperor, but the idea of an emperor, a position, a role, a shape that the next man could step into, and the world would keep turning. His stepson Tiberius took his place. Then others followed. Some were capable, some were strange, some were genuinely terrible, but the machine kept running. The armies marched, the grain ships sailed, the courts held their sessions. The roads carried the endless traffic of soldiers and merchants and messengers and pilgrims. Rome had become, in some deep structural sense, larger than any single person who sat at its center. This is what an empire is, at its heart. Not a man, a system. And what a system it was. At its greatest extent, the Roman Empire stretched from the cold, rain-soaked edge of Britain in the northwest, where legionaries in heavy armor stood shivering on Hadrian's wall and stared out at the fog, all the way southeast to the baking deserts of Egypt and the distant shimmer of the Euphrates River in Mesopotamia. It swallowed the Alps and the Rhine and the Danube. It wrapped around the entire Mediterranean Sea, that vast blue basin of trade and culture, as if the sea were a lake and Rome owned both its shores. 40 to 50 million people lived within its borders, speaking dozens of languages, worshipping hundreds of gods, eating different food and wearing different clothes and building their houses in different shapes. And yet they were all, in some meaningful sense, Romans, or they could be. The remarkable thing about Rome was how much it was willing to include. The roads made it possible. If you have heard one thing about ancient Rome, it is probably this: all roads led to Rome. And while that is not quite literally true, it is not far wrong either. The Romans built roads the way other civilizations built temples, with religious devotion, with extraordinary skill, and with the clear conviction that they were doing something that would last forever. They were right. A Roman road was not a dirt track beaten flat by feet and hooves. It was an engineered thing. Layers of sand and gravel and crushed stone and fitted paving blocks, raised slightly above the surrounding land so that rainwater drained to the sides rather than pooling and rotting the surface. The roads ran straight because the Romans believed, correctly, that the shortest distance between 2 points was a straight line, and they had the surveying skills and the stubborn determination to cut that line through whatever lay in the way. Forests were cleared. Hillsides were carved. Bridges were thrown across rivers with an offhand confidence that still impresses engineers today. Along these roads moved everything that kept the empire alive. Soldiers, marching in step, their sandals raising a steady rhythm on the stone. Merchants with wagons piled high with olive oil and wine, with pottery and silk and pepper from the Far East. Government officials carrying sealed letters, runners with urgent messages, ordinary travelers, families, pilgrims, traders, making the way from one end of the known world to the other. The roads were also how ideas moved, how Latin spread, how Roman law crept into distant provinces, how in time a new religion called Christianity, born in a small corner of the Eastern Empire, among people who had no particular reason to love Rome, was spread until it had reached every coast the roads could touch. But the roads, impressive as they were only the beginning. Step into a Roman city of the imperial age, any city, in Italy or Spain or North Africa or Syria, and you would find yourself somewhere surprisingly familiar. Not identical to a modern city, but recognizable in its bones. There were streets laid out in careful grids. There were markets busy with commerce. There were public spaces, the forum at the center of town, where people gathered to talk and argue and conduct their business, that served the same purpose as a town square anywhere, in any era. There were bathhouses. This is one of the details that tends to surprise people. The Romans were devoted to bathing in a way that was unusual for the ancient world, and the bathhouses, the thermae, were far more than places to get clean. They were social institutions. You went to the baths the way people today might go to a cafe or a gym or a public park. You soaked in warm rooms and hot rooms and cold plunge pools. You got a massage. You played board games. You argued about politics. You made business deals. You gossiped. The bathhouses were where Roman civic life actually happened, in the warm, steamy, surprisingly democratic space between one citizen and another. The water for all this, for the baths and the public fountains in the private homes of the wealthy, came via the aqueducts. These were engineering marvels of the highest order, long channels, sometimes running for dozens of miles, carrying fresh water from mountain springs down into the city at a perfectly calculated gradient, using nothing but the pull of gravity. Some of these aqueducts crossed valleys on towering stone arches, structures so well built that pieces of them still stand today, 2,000 years later, looking almost ready to carry water again. The people who lived inside this world were as varied as the empire itself. At the top were the wealthy, senators and knights and great landowners who lived in elegant houses built around open courtyards, where fountains played and frescoes covered the walls in vivid colors: deep red, ocean blue, warm ochre yellow. They ate at long tables laden with foods from every corner of the empire. The children were educated by private tutors in Greek and Latin both. They kept slaves, many slaves, to run the households, to cook and clean and carry and teach and tend the gardens. Below them were the merchants and craftsmen, the backbone of the Roman economy, who worked long days in small shops that opened directly onto the street, selling bread or wine or cloth or pottery or ironwork or 100 other necessities. They lived modestly but often comfortably, in apartments above the shops or in the dense, noisy tenement buildings that packed the city's residential neighborhoods. And below them were the poor, the many, always the many, crowded into the upper floors of those same tenements, where the stairs were steep and the rooms were small, and the smell of the street rose up through the window in summer. They relied on the public grain dole, which the emperors maintained with great care, understanding that a hungry city was a dangerous one. They went to the public baths because they had no baths of their own. They gathered in the forums and the theaters and the amphitheaters because those spaces, unlike almost everything else in the ancient world, were truly public, open to all. The amphitheaters deserve a moment of honesty. The most famous of them, the Colosseum in Rome, finished in 80 AD under the Emperor Titus, was a wonder by any measure. It seated perhaps 50,000 people. Its system of vaulted arches and underground chambers was a masterpiece of engineering, and what happened inside it was, by modern standards, appalling. Gladiators fought each other, criminals were executed, wild animals, lions and bears and elephants brought from the far edges of the empire, were hunted and killed in the sand. The crowds watched and cheered and argued over their favorites, the way people today argue over sporting teams. It is uncomfortable to hold both things at once. That Rome built things of breathtaking beauty and engineered systems of extraordinary sophistication, and that it also filled its grandest building with blood for the entertainment of the masses. But history rarely offers us the luxury of simple admiration. The Romans were human beings, complicated, capable of great things and terrible ones, often in the same afternoon. The emperors of the Golden Age, Augustus, Vespasian, Trajan, Hadrian, Marcus Aurelius, each left their mark on the physical world as in stone and marble and bronze. Trajan pushed the borders of the empire to their furthest point, deep into what is now Romania, and built a column to celebrate it that still stands in Rome today. Its spiral of carved soldiers and battles rising 30 meters into the Italian sky. Hadrian traveled ceaselessly through his empire, inspecting and building and questioning, and left behind not just a wall across Britain, but a magnificent temple in Rome, the Pantheon, whose dome, a perfect hemisphere of poured concrete, remains the largest unreinforced concrete dome on Earth. Marcus Aurelius wrote a private journal of philosophical reflections, thoughts about duty and mortality, and how to be a good person in a world full of difficulty, and it has not been out of print since it was discovered. Even now, it is worth reading. The empire at its peak was not a perfect thing. No human construction ever is. But it was a real thing, enormous and humming and alive, connected by its roads and its laws and its shared language and its sheer improbable ambition. It believed it would last forever. Most things that believe that are wrong. Nothing lasts forever. This is perhaps the oldest truth there is, older than Rome, older than the hills it was built on, older than the river that still wound its slow way through the city long after the last emperor had gone. Every child knows it, in the way children know things before they have the words for them. Every summer ends, every fire burns down, every great and glittering thing, given enough time, goes quiet. Rome knew it too, in its bones, even at the height of its glory. The Roman poets wrote about it constantly, about how even stone crumbles, how even the mightiest cities return to grass and silence. They built their monuments to last, and they wrote their elegies about impermanence. And perhaps these two impulses were not contradictions at all. Perhaps you build most passionately precisely when you understand, somewhere deep in private, that what you are building will not stand forever. But knowing something is coming and feeling it arrive are very different things. The trouble did not begin all at once. It never does. It began at the edges. The Roman Empire was by the 2nd and 3rd centuries AD almost incomprehensibly large. To govern it properly, to move armies to where they were needed, to collect taxes, to administer justice, to keep the roads repaired and the grain flowing, required a degree of coordination that strained even Rome's remarkable administrative abilities. Messages took weeks to travel from the frontier to the capital. Decisions that needed to be made in days sometimes waited for months. The sheer physical scale of the thing was beginning to work against it. The way a tree that has grown too tall becomes vulnerable to the wind in ways a smaller tree never would. And there were winds. From the north and east, beyond the Rhine and the Danube, beyond Hadrian's Wall, beyond the last Roman outposts in the endless forests and grasslands, lived peoples the Romans called barbarians, a word that originally just meant foreigners, people who spoke languages that sounded to Roman ears like meaningless noise. Bar bar bar. These were not primitive people, despite what Roman writers sometimes claimed. They had their own complex societies, their own traditions of craftsmanship and warfare and law, their own fierce pride. And they had been pressing against Rome's borders for centuries, testing, probing, sometimes raiding, sometimes trading, sometimes simply waiting. In the 3rd century, the pressure became something more sustained. Tribes and confederations, the Goths and the Vandals, the Alemanni and the Franks, began moving against the empire's frontiers with a new urgency, driven partly by their own internal politics and partly by a great churning of peoples across the Eurasian steppe, one group pushing another westward like a slow and enormous wave. Rome pushed back. Rome always pushed back, but each time it cost more soldiers, more gold, more attention pulled away from the thousand other things an empire needs to survive. Inside the borders, things were shifting too. The economy, which had hummed along so reliably during the Golden Age, was showing cracks. Wars are expensive, and Rome had been fighting almost continuously for generations. The silver content of Roman coins, the denarius, that small disc of metal that had been the backbone of trade across the known world, was quietly, steadily reduced as emperors desperate for revenue stretched their resources thinner. Less silver meant the coins were worth less. Merchants noticed. Prices rose. People who had saved money in coins found that their savings bought less than they used to. The comfortable predictability of commerce began to fray. Tax collection thus became both more urgent and more brutal, as the state needed more money to pay its soldiers and its debts. In the countryside, farmers who had already lost so much over the previous centuries now found themselves squeezed still harder. Some simply abandoned the land and moved to the cities, or attached themselves to the estates of powerful local landowners who could offer some protection in exchange for labor and loyalty. This arrangement, a person tied to a piece of land, working it in exchange for the Lord's protection, was the seed of something that would flower more fully in the centuries after Rome, a world historians would call feudal. Rome planted it without knowing it. The emperors themselves became part of the problem. During the 3rd century, a period historians sometimes call the crisis of the 3rd century, which is one of those historical labels so accurate it almost makes you laugh. Rome went through more than 50 emperors in 50 years. Some reigned for a few months, some for a few weeks. They rose on the shoulders of their armies, and they fell when those same armies decided someone else might be more generous with the pay. Generals murdered emperors. Emperors executed rivals. The Senate, once the proud and quarrelsome heart of Roman governance, became increasingly ceremonial. A group of men who announced decisions made by soldiers, rather than making decisions themselves. This was deeply destabilizing, in the way that any institution is destabilized when its leadership changes constantly and violently. Confidence is fragile. People, merchants, farmers, city administrators, local officials need to believe that the rules will be the same tomorrow as they are today. When emperors change every few months, when loyalty to one man might mean death at the hands of his successor, people stop investing in the future. They stop building. They stop taking risks. They pull inward, protect what they have, and wait. There were attempts to stabilize things. Genuine, intelligent, sometimes heroic attempts. The Emperor Diocletian, who came to power in 284 AD after surviving the chaos of that terrible century, recognized that the empire had simply become too large for one man to govern. His solution was radical and logical in equal measure. He divided it, not into separate empires, at least not officially, but into 2 administrative halves, East and West, each with its own emperor and its own systems of government. The hope was that 2 centers of power could respond more quickly to the crises that kept erupting at the edges. It helped for a while. Constantine, who ruled in the early 4th century, made 2 decisions that would shape the next 1,000 years of history. The first was to embrace Christianity, that faith that had spread quietly along Rome's roads for 3 centuries, surviving persecution and misunderstanding, until it had woven itself into the fabric of the empire so thoroughly that suppressing it would have been like trying to remove the salt from seawater. Constantine did not suppress it. He adopted it, legalized it, supported it, built churches for it, and in doing so, set the Western world on a course it is still traveling. His second decision was to move the capital. He chose a city in the east, the ancient Greek city of Byzantium, sitting at the precise point where Europe and Asia nearly touch, a narrow channel of water between them like a held breath. He rebuilt it grandly and named it after himself, Constantinople, the city of Constantine. It was a wise choice, and it tells you something about where the real vitality of the empire now lived. The eastern half was richer, more urban, more commercially active, more deeply connected to the great trade routes that ran toward Persia and India and China. The eastern cities were ancient and sophisticated. The eastern provinces had not been so badly disrupted by the crisis of the previous century. The West was another matter. In the West, the pressure from outside never truly let up. The Visigoths, one of the Gothic peoples who had been pushing against Rome's borders for generations, had actually been allowed to settle inside the empire in large numbers, given land in exchange for military service. It was an arrangement that seemed practical, and it was, until it wasn't. Mistreated by corrupt Roman officials who cheated them of the supplies they had been promised, hungry and angry, the Visigoths rose. In 410 AD, under the king Alaric, they did something that had not happened in 800 years. They sacked Rome. They walked through the gates of the Eternal City and spent 3 days taking what they wanted. And while the damage was perhaps less total than the shock suggested, Rome was not burned to the ground. Its people were not all killed. The psychological wound was immense. The city that had believed itself eternal, the city that had stood at the center of the world for 1,000 years, had been broken open by people it had called barbarians. Augustine of Hippo, a theologian in North Africa, heard the news and sat down to write. He wrote for 13 years. The result was a book called The City of God, an argument that earthly cities always fall, that they are not the point, that something deeper and less perishable than marble and legions was what mattered. It is one of the most influential books ever written, born directly from the shock of Rome's humiliation. The Western Empire staggered on for another 66 years after Alaric's sack. Different groups moved through it. The Vandals, the Huns under the terrifying King Attila, the Ostrogoths. Each wave left it weaker, hollower, less able to defend itself or administer itself or believe in itself. And then, in 476 AD, a Germanic chieftain named Odoacer simply deposed the last Western emperor, a boy of 16 whose name, with a bitter poetry that history sometimes manages, was Romulus. The same name as the founder, the first and the last, sharing one name, separated by 12 centuries. Odoacer did not bother to appoint a new emperor. There was no one left who would have believed in the title. But the Eastern Empire, Constantinople, Byzantium, did not fall, not then, not for nearly 1,000 years more. It continued, reinventing itself century by century, keeping the Roman flame in a different vessel, until 1453 AD, when the Ottoman Turks finally took Constantinople and the last ember went out. And even then, it did not truly end, because Rome had already done what all great things eventually do. It had dissolved into everything around it. Its language became French and Spanish and Italian and Portuguese and Romanian. Its laws became the foundation on which European legal systems were built, and through them, the laws of half the world. Its calendar, adjusted and refined, is the one you use today when you check what day it is. Its architectural ideas, the arch, the dome, the column, are in almost every public building you have ever entered. Its name is still given to cities and months in the very script in which these words are written. So here is what the end of Rome actually looks like, if you step back far enough to see it properly. It does not look like a catastrophe. It looks like a river reaching the sea. The water does not stop. It does not disappear. It spreads out, wide and slow and quiet, mixing with everything it meets, becoming unrecognizable as a river and yet still, undeniably, water. Still moving, still carrying what it always carried. The roads outlasted the legions that built them. The laws outlasted the courts that administered them. The language outlasted the empire that spread it. And the idea that human beings might organize themselves into something larger than a family or a tribe, something built on shared rules and shared responsibilities, and the radical, difficult, never quite achieved notion that power should be limited and answerable. That idea did not die in 476 AD. It is still alive. You live inside it. And so the book slowly closes. The fire on the Palatine Hill has burned down to its embers. The forum is quiet. The colonnade silver in the moonlight. The stones still warm from the long day's sun. The Tiber moves as it always has, carrying its ancient cargo of memory downstream toward the sea. Somewhere, a wolf calls out once from the dark hills, and then is silent. And Rome, with all its noise and ambition, its cruelty and its beauty, its roads and its laws, and its long impossible story, breathes out slowly, like a sleeper settling into the deepest part of the night. Rest now. You have heard the whole story. And stories, even when they end, have a way of going on. Some countries have been shaped over centuries. Others have been shaped over millennia. India's history is not merely a succession of wars and rulers. It spans over 5,000 years of ideas, beliefs, discoveries, and changes. Philosophies were born here that outlasted empires, and empires that seemed eternal crumbled. And if stories this profound resonate with you, you can support this video by subscribing and liking it. And now, we turn to the first page. Before the pyramids of Egypt were raised, before Rome was even imagined, before Greece had written its first philosophy or China its first dynasty, there was a civilization growing quietly along the banks of a great river in the northwest of the subcontinent we now call India. It left no conquering armies in the historical record. It carved no monuments to warrior kings. It did not announce itself with the dramatic violence that most ancient civilizations used to make their mark on history. It simply built, carefully, intelligently, and with a patience that feels almost impossible to comprehend from where we stand today. This was the Indus Valley civilization, and it is one of the oldest, largest, and most quietly astonishing chapters in the entire human story. At its peak, roughly 4,000 to 5,000 years ago, the Indus Valley civilization covered an area larger than ancient Egypt and Mesopotamia combined. Its population may have reached several million people, spread across hundreds of settlements ranging from small villages to fully planned urban centers of extraordinary sophistication. The two most famous of these cities are Mohenjo-daro and Harappa, and what archaeologists found when they excavated them in the 20th century stopped the academic world in its tracks. These were not rough, improvised settlements scratched out of the earth by people barely surviving. They were planned, precisely, deliberately, almost obsessively planned. Streets laid out on a grid, running at right angles with a regularity that would not look out of place in a modern city. Houses built from standardized fired brick. The same dimensions used consistently across hundreds of kilometers of territory, suggesting a level of coordination and centralized decision-making that is remarkable for any era let alone 4,000 years ago. And beneath the streets, this is the detail that genuinely astonishes: a drainage and sewage system, a network of covered drains running through the city, connecting private homes to public disposal systems. At a time when most of the ancient world dealt with waste by simply leaving it somewhere inconvenient, the people of the Indus Valley were engineering sanitation solutions that would not be matched in Europe until the 19th century. Think about what that implies. Not just technical knowledge, but civic values. A collective understanding that the city belonged to everyone, that the health of one neighborhood affected another, that infrastructure was a shared responsibility. These were not just skilled engineers. They were, in some meaningful sense, citizens. Mohenjo-daro alone may have housed up to 40,000 people at its height. It had a large public bath, the Great Bath, a tank of waterproofed brick that was almost certainly used for ritual purification, suggesting an organized religious life as well as an organized civic one. It had granaries. It had what appeared to be assembly halls. It had a sophisticated system of weights and measures, standardized across the entire civilization, which tells us that trade was carefully regulated and that economic life was organized at a scale well beyond the local. And yet, and this is one of the most tantalizing mysteries in all of archaeology, we cannot read their writing. The Indus script, found on thousands of small seals and tablets, has never been deciphered. We do not know what language these people spoke. We do not know the names of their rulers, if they had them. We do not know their creation myths, their prayers, their laws. We have the physical evidence of a remarkably sophisticated civilization, the bones and infrastructure of a complex society, but the mind behind it remains sealed, silent, frustratingly out of reach. What we do know is that this civilization was, by the standards of its time, unusually peaceful. There is little evidence of large-scale warfare. No great fortifications designed to keep armies out, few weapons found in excavations, no monumental art glorifying military conquests. Whether this reflects genuine pacifism, geographical advantage, or simply evidence we have not yet found, no one can say with certainty. But the absence of the usual markers of ancient violence is striking. And then, somewhere around 1900 BCE, it began to end. Not with a bang, not with the conquering armies or a sudden catastrophe, though theories have included all of these. The current leading hypothesis is quieter and more unsettling: climate change. Shifts in monsoon patterns, possibly combined with the drying of the Gagara-Hakra river system that had fed many of the civilization's eastern settlements, gradually made agriculture more difficult and the cities less sustainable. People moved east toward the Ganges Plain, south into the interior. Slowly, over generations, the great cities emptied. Mohenjo-daro was abandoned. Harappa was abandoned. The drainage system silted up. The standardized bricks were reclaimed or buried. The writing stopped being written, or was written on materials that did not survive, or simply stopped. We cannot know which. A civilization that had lasted for nearly 1,000 years dissolved into the landscape, and the world moved on, not knowing what had been lost. Into this space, this vast ancient subcontinent with its river systems and its seasonal rains and its memories sealed in buried brick came new peoples, new languages, and new ideas. The exact nature of what happened next is one of the most debated questions in South Asian history and archaeology. For decades, the dominant narrative spoke of Aryan migrations, waves of people moving into the subcontinent from the steppes of Central Asia, bringing with them a language that would become Sanskrit and a set of religious and cultural practices that would form the foundation of what we now call Hinduism. More recent genetic and archaeological research has both complicated and, in broad strokes, supported this picture. There were significant movements of people into the subcontinent during the second millennium BCE, interacting and eventually integrating with the populations already there. What emerged from this long, complex process of migration and mixing was something new, a language, a literature, a way of understanding the world. The Vedas are among the oldest religious texts still in active use anywhere on earth, composed in Sanskrit over many centuries, beginning perhaps as early as 1500 to BCE and continuing for 1,000 years. They are not a single book, but a collection, hymns, ritual instructions, philosophical dialogues, cosmological speculations. The oldest of them, the Rig Veda, contains over 1,000 hymns addressed to a pantheon of gods: Indra, the storm god; Agni, the fire god; Varuna, the keeper of cosmic order. But alongside the ritual and the mythology, something else was happening in this text. People were asking questions, not just what should we offer to which god, but what is the nature of reality? What is consciousness? What is the self? The later Vedic texts, the Upanishads, pursue these questions with a philosophical intensity that feels surprisingly modern. Debates about the nature of the soul, the relationship between the individual and the universal, the meaning of existence conducted not through myth, but through reasoned argument. These were not primitive religious documents. They were the beginning of one of humanity's great intellectual traditions, one that would develop over the following millennia into philosophical schools of extraordinary depth and sophistication. A civilization had vanished, leaving its bricks and its mystery in the ground. A new world was forming, in language, in thought, in the slow accumulation of ideas about how human beings should live and what they owe each other and what, if anything, lies beneath the surface of visible reality. The subcontinent was vast. It held many peoples, many climates, many ways of life, and no single power controlled it. No single story could contain it. But the ideas being formed in those early centuries, the philosophical seeds being planted in Sanskrit verse, would prove more durable than any empire that came after. Empires, as India would repeatedly discover, are temporary. Ideas are not. Every civilization reaches a moment when it must choose what it wants to be, not in a single dramatic decision. History rarely works that cleanly. But over generations, through war and philosophy, and the slow pressure of ideas pushing against power, a society reveals its character, what it values, what it is willing to destroy, what it is willing to become. India's second great chapter is the story of that reckoning. It is the story of kingdoms learning to become empires, and of one man standing in the wreckage of a battlefield he himself had created, deciding that there had to be another way. By the middle of the first millennium BCE, the subcontinent had fragmented into a patchwork of kingdoms and republics, each jostling for territory and influence across the great river plains of the north. These were the Mahajanapadas, 16 major states, ranging from monarchies to early forms of republican governance, competing through diplomacies and warfare in patterns that would feel familiar to any student of history. It was a world of ambition, of armies and alliances, shifting borders and strategic marriages. A world that produced, as worlds under pressure tend to do, an unusual concentration of extraordinary minds, because it was also in this period, roughly between the 6th and 4th centuries BCE, that India experienced something that has no simple parallel in world history. A philosophical and spiritual explosion so concentrated, so diverse, and so intellectually serious that scholars sometimes speak of it in the same breath as the Greek Golden Age, the Chinese 100 schools of thought, and the Hebrew prophetic tradition, all of which were happening, remarkably, at roughly the same time. The German philosopher Karl Jaspers called it the Axial Age, a period when human consciousness, across multiple civilizations, simultaneously and apparently independently, turned inward and began asking harder questions. In India, two of those questions produced answers that would change the world. Siddhartha Gautama was born into a life of extraordinary privilege, a prince in a small kingdom in what is now southern Nepal, shielded from suffering by wealth and walls and the careful management of everything he was allowed to see. The story of his awakening begins with the moment those walls came down. A sick man, an old man, a corpse, a wandering ascetic, serene in the face of all of it. 4 encounters that cracked the protected world open and left a young man unable to go back inside. He left, spent years in the company of teachers and ascetics, pushing his body to extremes that nearly killed him. And then, sitting beneath a tree in Bodh Gaya, he found what he had been looking for, not through renunciation or ritual, but through a quality of attention so complete and so honest that it dissolved the usual boundaries between the observer and what was being observed. He became the Buddha, the awakened one. What he taught was not a theology in the conventional sense. There were no gods to pray to, no eternal soul to save. Instead, there was a clear-eyed diagnosis of human suffering, its causes rooted in craving, in the desperate human habit of clinging to things that cannot last, and a practical path toward its cessation. The Eightfold Path: right understanding, right intention, right speech, right action, right livelihood, right effort, right mindfulness, right concentration. It was at its core a philosophy of paying attention, of seeing clearly, of releasing the grip on permanence in a world where nothing is permanent. It spread, first across the subcontinent, then across Asia, then across the world. Today, roughly 500 million people identify as Buddhist. The ideas that began beneath a tree in northern India have shaped the art, ethics, law, and daily practice of civilizations from Japan to Sri Lanka, from Tibet to California. Not bad for a man who owned nothing and wrote nothing down. Around the same time, in the same general region, another tradition was crystallizing, one that would remain more rooted in the soil of the subcontinent itself. Jainism, formalized through the teachings of Mahavira, built its entire ethical architecture on a single foundational principle: ahimsa, non-violence, non-harm to any living being, in thought, word, or action. This was not a casual ethical preference. It was a total commitment, carried to lengths that most people would find extreme, but which expressed something philosophically serious about the nature of the world and the moral weight of every living thing within it. Jain monks swept the ground before them as they walked to avoid stepping on insects. They wore masks to avoid inhaling small creatures. They were, and remain, among the most consistent ethical vegans in the history of human thought. The concept of ahimsa did not stay within Jainism. It entered the broader current of Indian ethical thinking, resurfaced in Buddhism, and would eventually, 2,500 years later, become the central strategic tool of a man named Gandhi trying to end an empire. Ideas have long lived in India, but ideas, however powerful, do not build roads. They do not maintain armies or administer justice across thousands of kilometers of territory. For that, you need an empire. The Mauryan Empire, founded by Chandragupta Maurya around 321 BCE, was the first serious attempt to bring the vast majority of the subcontinent under a single political authority. Chandragupta was advised by one of the most remarkable political minds of the ancient world, Chanakya, whose treatise on statecraft, the Arthashastra, reads in places like a collaboration between Machiavelli and a modern management consultant. It covers everything from economic policy to espionage, from the proper management of ministers to the ideal dimensions of a king's bedroom. It is ruthlessly practical, occasionally brutal, and consistently brilliant. Under Chandragupta and his successors, the Mauryan Empire stretched from what is now Afghanistan in the west to Bengal in the east, from the Himalayas in the north, deep into the Deccan Plateau in the south. It was the largest empire the subcontinent had ever seen, and would not see again for nearly 2,000 years. And then came Ashoka. Ashoka inherited the empire from his father around 268 BCE and spent the early years of his reign doing what emperors did, consolidating power, suppressing rivals, expanding territory. He was capable, ambitious, and apparently quite ruthless. The historical record suggests he was not a gentleman by nature. Then, around 261 BCE, he fought the Kalinga War. Kalinga, on the eastern coast of India, resisted Mauryan expansion fiercely. The war was won, eventually, definitively. The Mauryan army was victorious, and the cost, by Ashoka's own account, carved in the rock edicts that still exist today, was staggering. 100,000 killed in battle, many more dying of wounds and starvation afterward, hundreds of thousands displaced. Ashoka walked the battlefield, and something in him broke open. What he saw, or rather, what he finally allowed himself to see, horrified him. The reality of what military victory actually looked like, stripped of the abstraction of strategy and the distance of command. The bodies, the grief, the particular and irreducible suffering of individual human beings caught in the machinery of imperial ambition. He turned to Buddhism, not merely as a private spiritual practice, but as a governing philosophy. And what followed was something so unusual in the ancient world that historians still debate how seriously to take it. An emperor genuinely attempting to rule through compassion rather than fear. He had edicts carved into rocks and pillars across the empire, statements of policy, ethical commitments, instructions to his administrators to treat the people under their care with kindness and fairness. He built hospitals for people and for animals. He planted trees along roads to provide shade for travelers. He sent Buddhist missionaries across Asia and into the Mediterranean world. He prohibited the slaughter of certain animals. He encouraged religious tolerance across the diverse face of his empire, instructing his officials not to disparage other sects. Was he perfect? No. Was the empire still an empire, still maintained by force? Yes. History does not produce saints, but Ashoka remains one of the most genuinely remarkable figures in the political history of the ancient world. A man who held enormous power and tried, with apparent sincerity, to use it well. After Ashoka, the Mauryan Empire gradually weakened and eventually collapsed, fragmenting back into the regional kingdoms from which it had been assembled. But then, several centuries later, came the Guptas. The Gupta Empire, which reached its peak between roughly 320 and 550 CEE, is remembered in Indian history as the Golden Age, and the description is not mere nostalgia. What was produced during this period in mathematics, astronomy, medicine, literature, philosophy, and art represents one of the great flowerings of human intellectual achievement. Indian mathematicians during the Gupta period formalized the concept of zero as a number, not merely as an absence, but as a quantity in its own right, capable of being used in calculation. This is not a minor achievement. Zero is the foundation upon which all modern mathematics, computing, and by extension, the entire technological world is built. Without zero, there is no algebra, no calculus, no binary code, no computer. Every device you have ever touched traces its conceptual ancestry to a mathematical idea developed in Gupta-era India. The astronomer Aryabhata calculated the approximate length of the solar year with remarkable precision, proposed that the Earth rotated on its axis, and estimated the value of pi to 4 decimal places, 1,000 years before European science arrived at equivalent conclusions. The physician Sushruta, working in this tradition, describes surgical procedures, including forms of rhinoplasty and cataract surgery, that wouldn't appear in European medical literature for over a millennium. All golden ages end. The Gupta Empire was weakened by invasions from the north and eventually fragmented, as the Mauryan Empire had fragmented before it. The political unity dissolved. The courts that had patronized scholarship dispersed. But the knowledge remained. It had been written down, copied, taught, transmitted, carried forward in manuscripts and in the minds of teachers, passing it to students who would pass it further still. Empires fall. They always fall. The ideas they shelter, if they are strong enough, do not. No civilization exists in isolation. Not really. Not for long. However vast its territory, however confident its rulers, however deep its traditions, eventually the world finds a way in, through trade routes and mountain passes, through the slow migration of peoples and the sudden violence of armies, through the invisible movement of ideas, carried in the minds of merchants and pilgrims and refugees. India has always known this. The subcontinent is not an island. It is a peninsula attached to the largest landmass on Earth, connected to Central Asia to the northwestern passes that have served for thousands of years as both gateway and wound. Through those passes came Alexander the Great, probing the edge of his ambition. Through them came the Kushans, the Huns, the Afghans. Through them came languages and religions and art forms that folded themselves into the extraordinary complexity of Indian civilization and never quite left. This is the chapter where the world arrived. And India, as it had always done, absorbed it. Not without pain, not without conflict, but with a depth and a stubbornness that proved in the end stronger than any army. After the fragmentation of the Gupta Empire, the subcontinent returned to the familiar pattern of regional kingdoms, each powerful in its own sphere, none dominant across the whole. The south developed its own great dynasties, the Cholas, the Pallavas, the Chalukyas, building temple complexes of staggering scale and beauty, projecting maritime power across Southeast Asia, trading with Rome and China and the Arab world simultaneously. The Chola Empire at its height was a naval power of genuine consequence. Its fleets crossed the Bay of Bengal and raided as far as Sumatra and the Malay Peninsula. Its bronze sculpture, particularly the dancing Nataraja, Shiva caught in the cosmic dance of creation and destruction, represents one of the supreme achievements of world art. These were not peripheral kingdoms scratching at the edges of civilization. They were civilization in the fullest sense of the word. Meanwhile, in the north, the patchwork of kingdoms held, each developing its own culture, its own architecture, its own synthesis of the Hindu and Buddhist traditions that had been accumulating for 1,000 years. And then the passes opened again. Islam had been born in the Arabian Peninsula in the 7th century CE and spread with extraordinary speed across the Middle East, North Africa, Persia, and Central Asia. By the 8th century, Arab armies had reached the Sindh region of what is now Pakistan. It was an early contact, significant, but limited in immediate impact. The deeper transformation came later, and from a different direction. Beginning in the early 11th century, Mahmud of Ghazni launched a series of raids into the subcontinent from Afghanistan, 17 expeditions over 25 years, targeting the wealthy temples of the north and carrying their treasures back across the passes. These were not conquests in the administrative sense. They were raids, devastating, destructive, and deeply traumatic in the cultural memory they left behind. But they did not attempt to govern the territories they plundered. Permanent change came with the Ghurid invasions of the late 12th century. Muhammad of Ghor defeated the Rajput Confederacy at the Second Battle of Tarain in 1192, one of those pivot point moments where a single afternoon on a battlefield reshapes centuries of what follows. The defeat broke the political power of the Rajput kingdoms of northern India and opened the Gangetic plain to a new kind of authority. What emerged from that authority was the Delhi Sultanate, 5 successive dynasties, ruling from Delhi across much of northern India for 3.5 centuries, from 1206 to 1526. The arrival of Islamic political power in India was not a simple story of conquest and suppression. It was messy and complicated and human, which is to say it contained multitudes. There was destruction. Temples were demolished, some for their stone, some as statements of political and religious authority, some in the heat of warfare. Established social and cultural patterns were disrupted. The trauma was real, and its memory long. But there was also synthesis. There always is, when peoples live together long enough. Persian became the language of administration and court culture, and in that encounter between Persian and the languages of northern India, something new began to form, a vernacular that would eventually become Urdu, carrying both streams within it. Music fused, architecture fused. The great temples of the south and the mosques of the north influence each other in ways visible in the buildings that survive today. Sufi mystics, Muslim teachers who emphasize direct personal experience of the divine over legalistic orthodoxy, found willing audiences across the subcontinent and in many places developed relationships of genuine exchange with Hindu and Buddhist practitioners, pursuing their own forms of mystical experience. The Bhakti movement, which swept through India during the centuries of the Sultanate, expressed something essential about how Indian spirituality responded to this moment. Its poet saints, Kabir, Mirabai, Tukaram, Ravidas, sang devotional poetry that crossed and questioned the boundaries of caste and religion simultaneously. Kabir, perhaps the most remarkable of them, was claimed by both Hindus and Muslims after his death and belonged fully to neither. His verses pointed past all institutions toward something more immediate, more personal, more stubbornly human. If you search for me, I am right next to you. The Sultanate period produced, alongside its violence, a civilization of genuine richness and complexity. It laid the administrative and cultural groundwork for what came next, the most dazzling chapter in the long story of Islamic rule in India. The Mughal Empire arrived in 1526, when Babur, a Central Asian prince who had lost his ancestral kingdom of Fergana and spent years fighting to find somewhere to belong, crossed the passes with a smaller but better equipped army and defeated the last Delhi Sultan at the First Battle of Panipat. Babur was a remarkable man almost despite himself, a warrior who wrote poetry, a conqueror who kept a detailed memoir describing the flowers and melons of the lands he moved through with a botanist's loving attention. His Baburnama is one of the great autobiographical documents of the medieval world, luminous and unexpectedly tender. But it was his grandson who made the empire what it became. Akbar the Great ruled from 1556 to 1605 and stands as one of the genuinely extraordinary figures in the political history of any civilization. He was illiterate, never learned to read, despite being surrounded by the finest books and scholars in the empire, and yet built an administration of remarkable sophistication, presided over a court that was one of the great intellectual centers of the 16th century world, and pursued a policy of religious tolerance so systematic and sincere that it remains striking even today. He abolished the jizya, the tax on non-Muslim subjects. He married Rajput Hindu princesses and respected their religious practices within the imperial household. He invited scholars of every faith, Hindu, Muslim, Jain, Zoroastrian, Christian, Jew, to his court for debates about religion and philosophy that he attended with genuine curiosity. He eventually developed his own syncretic spiritual philosophy, Din-e-Ilahi, attempting to find the common ground beneath the competing traditions. Whether this was sincere spiritual seeking or brilliant political management. Probably it was both. The result was an empire that held an extraordinarily diverse population together to something more sophisticated than simple force. And then there was the Taj Mahal. Shah Jahan, Akbar's grandson, built it between 1632 and 1653 as a tomb for his wife, Mumtaz Mahal, who died giving birth to their 14th child. 20,000 workers, 22 years. White marble brought from Rajasthan, precious stones inlaid from across Asia and the Middle East. It is the most visited building on earth, and standing before it, even in photographs, even in the most reproduced image in human history, something in the proportion and the light refuses to become ordinary. It does not look like power. It looks like grief made permanent, like a man reaching for the only language adequate to loss and finding, somehow, the right words. The Mughal Empire eventually weakened. Aurangzeb, Shah Jahan's son, reversed much of Akbar's tolerance, reimposing the jizya, demolishing temples, alienating the Hindu and Sikh populations whose cooperation had been central to the empire's stability. Regional powers reasserted themselves. The Marathas rose in the south and west. The Sikhs consolidated power in the Punjab. The great empire fragmented, as all great empires do, into the pieces from which it had been assembled, and into that fragmentation, from the coastal trading posts they had been quietly expanding for a century, came the British. But that is the next chapter. Every empire tells itself a story in which its presence is justified, necessary, even generous. A story in which the roads it builds matter more than the wealth it extracts, in which the order it imposes is a gift rather than a cage, in which the people living under its authority should, by any reasonable measure, be grateful. Britain told itself this story about India for nearly 2 centuries. India told a different one. It did not begin as conquest. It rarely does. The British East India Company arrived on the shores of the subcontinent in 1608, not as an army, but as a trading enterprise. Spices, textiles, the extraordinary Indian cotton that European markets could not get enough of. The Mughal Empire was still powerful then, still the dominant political authority across most of northern India, and the company's early representatives came as supplicants, negotiating trading rights with emperors who had little reason to take them particularly seriously. For a long time, that was the relationship: trade, profit. A few coastal settlements, Surat, Madras, Bombay, Calcutta, where company merchants lived and worked under the distant authority of an empire they could not yet dream of replacing. But the Mughal Empire was weakening. The great edifice that Akbar had built was cracking under the pressure of overextension, religious conflict, and the centrifugal pull of regional powers asserting their independence. And into that cracking structure, the East India Company began, carefully and then less carefully, to insert itself. It signed treaties. It backed local rulers in their disputes with other local rulers in exchange for concessions. It raised its own armies, not British soldiers, but Indian soldiers, sepoys, trained and equipped in the European manner and loyal for a price to the company's authority. It fought, and it won. And with each victory, the territory under its control expanded, and the fiction that it was merely a trading enterprise became harder to maintain. By the mid-18th century, the company was not a merchant, it was a government. One of the strangest governments in history, a private corporation, accountable to shareholders in London, administering the lives of tens of millions of people across the subcontinent in the name of profit. The mechanisms of extraction were systematic, and once you understand them, breathtaking in their audacity. India was, at the beginning of the 18th century, one of the wealthiest regions on Earth. It produced roughly a quarter of global economic output. Its textile industry was the most sophisticated in the world. Indian cotton and silk were sold across Asia, the Middle East, and Europe, desired everywhere for their quality and variety. The company, and later the British Crown, dismantled this. Indian textiles were taxed out of competitiveness in British markets, while British machine-made cloths flooded India tariff-free. Weavers who had sustained their families for generations found their livelihoods destroyed, not by inferior skill, but by deliberately engineered trade policy. Raw materials flowed out of India to fuel British factories. Finished goods flowed back in for Indian consumers to buy. The subcontinent was repositioned systematically from a manufacturer to a supplier of raw materials, a structural change whose consequences lasted well beyond independence. The railways, so often cited as Britain's great gift to India, were built primarily to move goods from interior to port, to extract efficiently what the land produced. They were financed by Indian capital at guaranteed profit rates paid by Indian taxpayers, and built largely for British commercial benefit. That they also connected people and places and eventually served the independence movement is true. That they were built for India's benefit is not. The rebellion came in 1857. It began among the sepoys, the Indian soldiers who formed the backbone of the company's military power. The immediate trigger was cartridges, rumored to be greased with the fat of cows and pigs, offensive to Hindu and Muslim soldiers respectively. But the cartridge was merely the spark. The fuel had been accumulating for decades, resentment of cultural interference, anger at land policies that had dispossessed local rulers and peasants alike, the humiliation of a people governed as subjects rather than citizens in their own land. The rebellion spread across northern and central India. It was fierce and it was brutal on both sides. Atrocities were committed by both the rebels and the British forces that suppressed them. When it was finally crushed, the consequences were total. The East India Company, that extraordinary fiction of a corporate empire, was dissolved. The British Crown assumed direct control. India became, officially and without further pretense, a colony. Queen Victoria was proclaimed Empress of India in 1877. The cage had a new name. The door remained locked. And then, in the early 20th century, a man stepped off a ship in Bombay after years in South Africa and began, quietly, to change everything. Mohandas Karamchand Gandhi had developed in South Africa a method of political resistance that drew on the deepest currents of Indian philosophical tradition, on ahimsa, on the Jain and Buddhist insistence that the means by which you fight shape the ends you can achieve, on the Bhagavad Gita's teaching about action without attachment to outcome. He called it Satyagraha, truth force, soul force. The strategy was not passive. It was not simply the absence of violence. It was the active, disciplined, courageous refusal to cooperate with injustice, accepting the consequences of that refusal without retaliation, making the moral cost of oppression visible to the world and unsustainable for the oppressor. It required extraordinary courage. Civil disobedience is easy to romanticize from a distance. Up close, it meant beatings, imprisonment, the slow, grinding psychological pressure of a system designed to make resistance feel futile. Gandhi went to prison repeatedly. So did thousands who followed him: lawyers, farmers, students, women who had never before entered public life, stepping forward into the machinery of colonial authority and refusing to move. The Salt March of 1930 captured it perfectly. Gandhi walked 240 miles to the sea to make salt, a simple, ancient act that the British had made illegal in order to maintain their salt monopoly. He was 71 years old. Thousands joined him along the route. When they arrived and he lifted a handful of salt from the shore, the symbolic power of the act was felt across the world. Here was a man breaking an unjust law in the most peaceful, deliberate, and public way imaginable, and daring the empire to respond. The empire responded by arresting 60,000 people and losing the argument completely. Independence came on the 15th of August, 1947. Jawaharlal Nehru, India's first Prime Minister, spoke at midnight to a nation finally its own. A tryst with destiny, he called it. A moment long suppressed, now arriving at last. But it did not arrive cleanly. The partition of the subcontinent into India and Pakistan, drawn hastily along religious lines by a British lawyer who had never visited India and completed in 5 weeks, produced one of the largest and most violent mass migrations in human history. Somewhere between 10 and 20 million people moved, crossing the new borders in both directions. Between 200,000 and 2 million were killed in the communal violence that accompanied the petition. Families were separated. Villages that had been mixed for generations became suddenly, terrifyingly dangerous. Gandhi, who had spent his life working towards this moment, was heartbroken by the violence. He fasted. He walked through riot-torn areas, placing his body in the space between communities tearing each other apart. He was assassinated in January 1948 by a Hindu nationalist who believed he had been too sympathetic to Muslims. Freedom had arrived. It had arrived with grief wrapped around it. History does not give clean endings. It gives turning points, moments where the direction changes, where the accumulated weight of what came before meets the possibility of what might come next, and something new begins to form in the space between them. 1947 was such a moment. The empire was gone. The subcontinent was scarred. And an ancient civilization carrying 5,000 years of memory turned to face what came next. Independence is not an ending. It never is. The moment the British flag came down and the Indian tricolor rose in its place, the real work began. Not the work of resistance. That chapter, extraordinary and costly as it was, had reached its conclusion. The work that followed was harder in a different way. Quieter, less cinematic. The work of building something from the inside, rather than dismantling something from the outside. India in 1947 was not a blank page. It was a page covered in centuries of writing, of caste and language and religion and regional identity and the fresh, unhealed wounds of partition. To take all of that and construct from it a functioning democracy was an ambition so enormous that many serious observers, at the time, considered it essentially impossible. They were wrong. The Constitution of India came into force on the 26th of January 1950. It was and remains one of the most ambitious constitutional documents ever written, the longest national constitution in the world, exhaustively detailed, hard-won in every clause, carrying the fingerprints of B.R. Ambedkar, its chief architect, on every page. Ambedkar was himself a living argument against the old order, born into an untouchable caste at the very bottom of a hierarchy that had denied his humanity before he had the chance to demonstrate it. He became one of the finest legal minds of his generation and used that mind to dismantle, in law at least, the system that had tried to erase him. The Constitution abolished untouchability. It guaranteed fundamental rights regardless of caste, religion, or gender. It established universal adult suffrage. Every citizen, literate or not, wealthy or not, of any caste or faith, with an equal vote. In a country where the majority of the population had never been asked their opinion about anything, this was not a small gesture. It was a revolution conducted through paperwork rather than gunfire. And it was, in its own way, as radical as anything that had come before. The early decades were defined by Nehru, brilliant, secular, idealistic, complicated. He envisioned an India that was modern without abandoning its traditions, socialist in its economics without becoming Soviet in its politics, non-aligned in the Cold War that was restructuring the rest of the world around two competing poles. He built institutions, the Indian Institutes of Technology, the great dams he called the temples of modern India, a framework of democratic governance that survived his death and the deaths of those who came after him. He also made mistakes. The border war with China in 1962 exposed military unpreparedness that damaged his reputation and, some argue, his health. The economic model he chose, heavily state-directed, suspicious of private enterprise, protected from foreign competition, produced stability but also stagnation, a bureaucratic weight that slowed India's potential for decades. History does not produce perfect leaders. It produces people making decisions under pressure with incomplete information, and Nehru was that, gifted and flawed and irreplaceable in the particular moment he occupied. The India that emerged through the second half of the 20th century was not one country in any simple sense. It was, and is, a civilization containing multitudes, 22 officially recognized languages, hundreds of dialects, a religious landscape of staggering diversity, Hindus, Muslims, Sikhs, Christians, Jains, Buddhists, Zoroastrians, Jews, communities whose presence on the subcontinent spanned centuries and millennia, living alongside each other in arrangements of coexistence that are sometimes harmonious, sometimes tense, occasionally violent, but persistently, stubbornly continuing. The tensions are real. Communal violence has erupted periodically in 1984, in 1992, in 2002, leaving wounds that have not fully closed. The caste system, abolished in law, persists in practice in ways that continue to shape opportunity and deny dignity to hundreds of millions of people. Inequality is vast. The distance between the India of glass towers and technology campuses and the India of rural villages without reliable electricity or clean water is not merely economic. It is temporal. People living within the same country in what feel like entirely different centuries. And yet, the democracy holds. Elections happen. Enormous, chaotic, logistically extraordinary exercises involving nearly 1 billion eligible voters, carried out with a regularity and a basic integrity that most of the world's democracies would recognize as legitimate. Power has transferred peacefully between opposing parties. Courts have ruled against governments, and the governments have, however, reluctantly complied. The institutions Ambedkar and Nehru and the constitution makers built have proven more durable than the cynics expected. In 1991, India made a choice that changed its economic trajectory permanently. Facing a balance of payments crisis so severe that the government flew gold reserves to London as collateral for an emergency loan, India liberalized its economy, dismantling the thicket of licenses and restrictions that had strangled private enterprise for decades, opening to foreign investment, allowing the market forces that had been held at arm's length to finally enter. What followed was not immediate paradise. Economic liberalization creates winners and losers, and the losers are always more visible, at least at first. But over the following 3 decades, India's economy grew at rates that transformed the country. A middle class emerged on a scale that had no precedent in Indian history. The technology sector, particularly in Bangalore, which became one of the world's great hubs of software development, put Indian talent on the global map in a way that colonial-era Britain, which had systematically undervalued that talent, could never have imagined. India is now the 5th largest economy in the world. It will likely be the 3rd within a decade. And yet the numbers, impressive as they are, miss something. What is most remarkable about modern India is not its GDP. It is the sheer, almost incomprehensible fact of its continuity. A civilization that was composing philosophical texts 4,000 years ago is still here, still arguing, still creating, still absorbing and transforming whatever the world sends through its passes and across its shores. The ancient temples still stand next to glass office buildings. Classical music traditions maintained across 100 generations are performed in concert halls, where the audience carries smartphones. Sanskrit scholars and machine learning engineers share a city. The past is not museum piece here. It is alive, present, occasionally inconvenient, always relevant. 5,000 years of accumulated human experience does not disappear. It sediments, layer upon layer, each era leaving something behind that the next builds upon or pushes against or quietly absorbs without noticing. India's story is not finished. It is not close to finished. The questions it is wrestling with right now about identity and belonging, about the relationship between its Hindu majority and its vast religious minorities, about inequality and opportunity, about what kind of democracy it wants to be in the 21st century, are not small questions. They are the questions that will shape not just one country, but a significant portion of humanity's future. 5,000 years of wisdom does not guarantee the right answers, but it does mean the questions have been asked before in different forms by people who left their thinking behind in texts, in temples, and the left traditions of communities that somehow, against considerable odds, survived. That inheritance is not nothing. It may, in the end, be everything. If this journey through 5,000 years of one of humanity's greatest civilizations gave you something, a thought, a question, a moment of genuine wonder, then share it with someone who deserves to feel the same. And if you stayed until the end, through every chapter, every empire, and every idea, alike is the simplest and most honest way to say that this kind of storytelling matters to you. It matters enormously to us. Sleep well. India has been here for 5,000 years. It will be here in the morning. It always is.